Hi everyone. So we'll kick off. Thank you all for coming along and those online as well. So welcome to day 2 of our BPRC conference. Couple of small housekeeping matters. Please remember to use the hashtag, #Bioprotection21. So a number of you have been, thank you. Peter is regretting one of the comments he made yesterday that seems to be trending. Also, because of the disruption with Wellington, one of our speakers this morning, Aotearoa Mead, is going to be via Zoom. We're hoping it all goes well. We do have a contingency plan in case. And I think that's all I needed to add. So it's my pleasure to invite Matua Hanare to open with Karakia.
Atamaria kia tātou katoa. Good morning, everyone. As we head into the second day of our conference. Ngā mihi nunui kia koutou katoa. Thank you for being here, and obviously there are some empty seats here where people have had to go back to Auckland or Wellington in particular. So our thoughts are with they and their families as well, and the people of Wellington. So as we launch into our second day, let us open in karakia. Kia ino e tātou. E hoa ngā mono, kei te rangi te tihi o tau Aotearoa, kei te mato te whenua tau tūranga wāwai kei ngā wāhi katoa tau Claudia Tanganui. E te matua e te tamata wairua tapu me ngā anahera pono. Tēnei rā mātu aupunanga iti e tū koropiko nei mātu ki mōtō aroaro. Tukake nei ko te reo whakamoimiti Claudia Honore me ngā whakawhetai. Tēnei rā e hoa e hakawhetana mōu manaakitanga i whiwhiai a mātu katoa. Mai o ngā wā ki muri taino mai rā ki tēnei haora o tēnei ata. Tēnei rā ka tuku tēnei o mātou ino ki mōtō aroaro i tēnei wā. Kia whakatata mai rā koe kia mātou. I roto ngā mahi ko mahitia nei mātou kei moi a mātou. Nā reira e te matua tēnei rā kainua ke nei kia koe i tēnei wā. Tukua mai o koutou karere ana hera. Ki mua ki muri ki runga ki raro ki ngā tahataha katoa. Te ata whai arahi ai mātou i runga ngā kaupapa mo te rā nei. Nō reira e te matua tēnei te tangi atu nei mātou kia koe. I roto e nei inoi kohorehia nei mātou ki mua i a koutou i tēnei wā. Ka inoi nei mātou mo te tini o rātou e noho mai ana i roto te rā o ngā wāhi o te upoko o te ika. Kia tau ai o manaakitanga kei runga i a rātou katoa. Rātou e noho mai ana e pēhi ana Tēnei mate uru tā kei runga i a rātou. Nā reira koe a rā ka tuku nei, ene o mātou inoi, kia rātou puta noa kia mātou katoa. Tēnei ka inoa ke nei kia koutou kei runga tunu te ingo tapu o te matua, te tama, te wairua tapu me ngā anahera pono. Kei roto tonu ko koe te māngai te kai āwhina. Te kai āwhina mai rā i a mātou, ai ni āka nei ai. Ka tira i tēnei wā, hara mai, hoki mai, tēnā koutou, tēnā rā koutou i tēnei ata. So welcome back again to everyone who are here present. And what a wonderful day we had yesterday. What a wonderful day. And there's no indication that today won't be similar. So just while I'm here, I want to thus far thank everyone who participated, the organisers, and many of those who squirrel behind the scenes, that we don't see them. So to make this so far such a successful conference. And of course to yourselves, for if it were not for you, then it won't be a successful conference. And what you bring and give to this conference, to be sitting amongst you here, it's quite awesome to be amongst you here. The knowledge that is captured in this very room here this morning from you that you hold, and knowing full well that what you hold in knowledge, it makes me feel quite confident in moving forward the future for our mokopuna. And it's a we and not an I. We think of our mokopuna. In situations such as this, those who are not yet born into this world. So all the work that you do and the dedication that you give. And we will never stop searching and searching for the knowledge that we seek. Nō reira, I mihi to you all. Tēnā koutou, tēnā tātou katoa. Kia ora mai.
And thank you. So we have about 5 minutes until we really want to officially start, so we get on time for all the streaming. So we will just have a small hiatus of 5 minutes and then make a start. So only 5 minutes today, not 15 like yesterday.
Aotearoa and kia koutou. Kia ora mātua. That was a fantastic summary of yesterday. It was a interesting kōrero from all our speakers, and there were various challenges and wero which we hope will continue in today's session. But I'm Nick Waipura, and I'm the chair for the next session, and we're going to have an action-packed range of speakers, and it's the Te Taio, the Environment Conservation session, which is dear to my heart. And so, namihi koutou, so welcome everyone, tēnā koutou, tēnā koutou, tēnā koutou katoa. So first up today, we have our plenary, and Dan Cooper is from the Q2 National Trust and based in Wellington, but we'll forgive him for that. And he's going to be our plenary today and open it. And it's one of the kaupapa of conservation is often boxed into lands between what's managed by Te Papa Atapai or Department of Conservation and what's over here and what's over here. But in Te Ao Māori, it's the whenua, it's the ngāhere, it's the ecosystem. So there are no divides about where the whenua stop and start. So I'm really pleased and honoured that Dan has chosen us to come here today. So kia ora and welcome. Ho mai te pake pake.
Kia ora, Nick. Kia ora mātua. Kia ora koutou. Thanks for listening to me, and thanks for the invite. So I work for a place called the Q2 National Trust. Just a little bit about me. My working life has actually been in the agriculture sector. Most recently something called deer industry in New Zealand, before that the meat industry, before that the dairy industry. But before that I was kind of a scientist. I did genetics and molecular biology back when that was a little bit prehistoric. So, topic of the presentation, I was trying to be a little bit cheeky, private land, the other conservation estate. So just kind of echoing Nick's introduction there, we're a conservation organisation, Kiwi2, I'll get to that. But I kind of sometimes feel slightly grumpy when people talk about the conservation estate as if it's the place where conservation takes place. And my clear view is that conservation is a practice rather than a place, and we need to be thinking about the entire picture. And possibly those of you who are interested in science around biodiversity and bioprotection of biodiversity need to think pretty broadly about what conservation is and where it is as well. Hashtag Bioprotection21, sorry, I don't know how to do that. So what I will talk to you about are just four things is what I'm going to tell you. My view on what private land conservation is, what QE2 does in that space, what our role is, the opportunities and challenges around private land biodiversity, or at least the QE2 style of private land biodiversity, and then just, you guys are the bioprotection people, but just a few thoughts at the end there about, what I think might be places to look. So, private land conservation, this is my view. I'm not an academic, I haven't studied this in detail, but I'll give you three categories to put it under. The first is what QE2 really specialises in and what it was set up to do, which is a block of conservation land within a larger commercial landowning operation. In most cases, that's a pastoral farming operation. I'll show you some pictures. The second one is, probably much more prevalent in the last few, maybe decade than what it was before that, is actually really keen conservation type people who go out and buy a property specifically for the purpose of doing biodiversity protection on it. And then the third one, this is where you've got to think broadly, is it's not confined to a place, it's actually a landscape scale project being undertaken by a group of people, either with a formal leadership or just on an emergent community basis. So I'll just show you some pictures to illustrate those three things. Number one, this is a pretty, well, it's not really that typical, but This is what QE2 specialises in. This is a chunk of kahikatea forest in the middle of a really well-utilised, productive landscape. That one's probably unusual because the biodiversity is on really flat, easy land that someone could easily put a dairy cow on. Another example of that, category 1, so that's a wetland. Again, you can see the pasture in the background, so this is a highly productive landscape. Third example of the same thing, this is a bit more typical, so that's on a side of a hill, it's probably southerly facing, less productive, so for some reason it got left alone some hundreds of years ago, and now it's there for conservation purposes. Category 2, I was trying to look for some examples that didn't have a privacy issue, but this is a place called Aotearoa Forest Estate. This is in the Coromandel Peninsula. There's actually, in that yellow highlighted area, there's actually 27 titles there, but these were marketed some 15 or 20 years ago as conservation titles. So people, if they wanted to buy one, had to be interested in conserving the bush that was on there. So those were covenanted with QE2 before people got to buy them. This place is actually really impressive, and the little pictures on the right there, Peripatus, the Coromandel striped gecko, and the residents, the kind of citizens who lived there discovered the Coromandel striped gecko on their properties. Archie's frog, which is probably New Zealand's rarest native frog, and the forest ringlet butterfly. So these are all highly endangered species that exist primarily. Their stronghold is in this spot in the middle of the Coromandel that's in private ownership. Yeah. So the folk from DOC come here to have a look at Archie's frogs. The third example, this is the landscape scale thing. This is where I live. This is commonly known as the Miramar Peninsula, out in the middle of Te Whanganui a Tara, the great harbour of Tara. This actually is where Tara and his sons had their first settlement when they came to Wellington. At that time it was known as Te Motu Kairangi, the Kairangi Island, because the little isthmus, and this spot down here is Wellington Airport. That isthmus that the airport is on was actually another channel into the harbour, so that was an island. So I had some quite interesting biodiversity, some of which is still there. And what we're doing there is something called predator-free Miramar, whereby we're trying to kill off all the mustelids and rats and possums and such like. And we're kind of most of the way there. But this is community-driven conservation on a broad scale. It's not fixed in a place. It's about a bunch of people really doing a thing together. So that's kind of my definitions of private land conservation. Why is that important? Well, really simply, 70% of New Zealand is in private ownership. So if you want to have conservation going on across New Zealand, you're going to need to include the private land in that. Secondarily, the private land is where we went first, right? So when New Zealanders came, both Māori and European people arrived, the places they wanted to be and settle and develop were the flat, easy coastal places, and that's where the people still are, and that's the land that's in private ownership. The stuff that was tough to get to, that wasn't so fertile, that's the stuff that's now our public conservation land. So that's at the top of hill. So there's plenty of that, right? There's a lot of beach forest in conservation, but what there isn't is lowland ecosystems, dunelands, wetlands are under heavy threat, coastal forests. These are very rare, so any little bit of it you can find, it's really important to try and protect that. And where you find it is on private land. So that's why private land is particularly important from a biodiversity perspective if we want to have any hope of retaining those rare ecosystems. So that's private land biodiversity kind of. What's my role in that, or what's my organisation's role in that? I'll tell you a little bit about what QE2 is first. People who are focused on the agriculture sector probably know, but I suspect there's some of you who don't. Anyone who lives in town doesn't know what QE2 does. When I said I got a job at QE2, people said, "Oh, that swimming pool in Christchurch. Okay, that's cool. Didn't know you liked swimming." I don't like swimming. So, Independent Charitable Trust, it's set up under its own Act of Parliament, was set up in 1977. just if 1977 doesn't mean anything to you, that's pre-formation of the Department of Conservation. We are funded, about 80% comes through a government grant, and increasingly we're relying on charitable donations to get done what we need to get done. The concept at the time, and the flavour is still there, is by farmers for farmers. So the history of it was actually that this is in the late 70s, early 80s, when government was actually incentivising and pressing quite hard for development of land. Drain the swamp, clear the scrub, and create more productivity out of the land so we can redress our balance of payments issue. And there was a few farmers who actually were pushing back against this and saying, well, actually, no, I quite like that bit of forest that I have on my property, and I would like for that to be there forever, even after I sell the place or let the boy have it. So it was a couple of leading people in Federated Farmers, actually, who pushed for the Act to be created. And so it was created in 1977. Apparently the story goes that the name QE2 was based on the fact that Rob Muldoon was a hardcore royalist, and they thought that would get it across the line with them if they named it after the Queen. So they did. I'm not sure what's going to happen when Charles becomes whatever it is. I think we'll keep. So what do? We partner with those private landowners to protect that chunk of land in perpetuity. So what does that look like? So our main business is covenants. So a covenant is a legal agreement reached voluntarily between the landowner and us that attaches to the title of the land. So that covenant will generally say, thou shalt not chop down the forest, graze the forest, build a quarry or a mine, develop, subdivide. So it's basically a legal prohibition over things that would compromise the biodiversity or some other conservation value. So I've been talking about biodiversity, but there are covenants that protect archaeological sites or sites of particular cultural or landscape imperative. But we're talking sort of 90% biodiversity. Physical protection, by and large, particularly if you're in a pastoral farming landscape, you need to put a fence around these things to protect them. QE2 will come to the party with half of the fencing money, which is one of the incentives we offer. And then we have a commitment that we will be there forever. So a QE2 person will go back and visit the landowner, either the original landowner or a successive landowner, and have a conversation with them about how the covenant values are being upheld. So that's kind of a monitoring and compliance exercise, but our method really is about relationship management. So we need to stay friends with those landowners. So that seems like a nice thing to do. Since 1977, I think that number's actually a little bit out of date, and we're up about 4,700 covenants and pushing towards 190,000 hectares. So just to give you a little bit of context, 180,000 hectares is about the size of Stewart Island. It's about the size of the 3 remaining North Island national parks. So it's a fair old chunk of land, and here's a picture of what they look like. We'll see if we can make the technology do something clever. Oh, ooh, come on. Give me some oohs, people. Hey, it's good. It's good. So there they are. It's kind of like the stars in the night sky. So lots of little dots. Yeah. Thank you. Thank you. That's what I wanted. So here they kind of are. That's not quite as impressive, is it? That was my backup in case the YouTube didn't work. So by and large, we're talking tiny little dots all over the country, 4,500 spread about the place. Oops, sorry, I didn't mean to do that. There are a couple of exceptions. So this fella down here is something called the Mahu Whenua Covenants, and this was a guy, Shania Twain's ex, who bought 4 high country Crown Pastoral Lease blocks, Soho, Motutapu, Coronet and one other that I can't remember right now. 50,000 hectares, so out of my 180,000, that's quite a big chunk, and it kind of distorts some of our figures. But by and large, we're talking much smaller blocks. This is kind of what's in them. So this is everything, and this is probably a more typical representation. All registered covenants. Oh, gee. This is mahu whenua, right? So this is high country, central Otago, and it's all, well, it's not all, it's mostly grassland, tussock land. But if you look at kind of our typical in any given year, what we're talking about is forest, and what we're talking about typically is secondary modified forest. So it's been turned over once, it's had the big potocups taken out for timber, but since then it's been left alone and it's regenerating nicely, and someone wants to look after it, so it's got a fence around it and a covenant over it. So how do we do that? How do you do it? Work with the willing. So essentially, our people, and we've got about 30 regional reps across the country, and they sit and wait for the phone to ring, except they're not sitting, they're running most of the time, they're pretty busy. But it's a reactive process, right? So people come to us and say, hey, I want to do that thing, and we say, sure, we can help. So it's the willing who are coming to us. It's heavily reliant on the reputation of both QE2 and that rep, so most of the kind of recommendations will come by word of mouth. The fact that QE2 and that rep are independent of any kind of regulatory agency is pretty important to people wanting to do this with us. And we will work individually with each landowner. It's not a one-size-fits-all, but the covenant document and the physical arrangements around protection of the place will be tailored to the person. So it's about looking after that person. So as I said earlier, it's heavily reliant on relationships and the creation of goodwill. And so you're going, well, why do people call? Why do they want to do that? And yeah, it's kind of surprising to me, but talking to a few, the answers are one or all of these three things. First of all, the landowner does actually care about that block of forest or that wetland, and they like it, and they want to make sure someone doesn't bulldoze it one day. They don't usually use the word biodiversity. They don't like long words like that, but they say, I like those trees, or I like the birds that live up there. Sorry, I'm being generalising. There are certainly those ones who buy land for conservation purposes certainly know what biodiversity is. The second kind of set of motivations is around farming pragmatism. So often the fence will be going around a pretty tricky gully on the farm that people tend to lose stock in anyway and doesn't grow much grass. So actually it doesn't make much sense to try and keep that in the farming system. And it's much easier to handle your stock if you can just go round that gully without them going in there and disappearing. The other sort of pragmatism is if you consider that biodiversity protection is part of your corporate ethos or brand, then doing the right thing is actually part of what you want your corporate values to be. So I'd call that sort of pragmatism. And then the third one is slightly difficult to define, but this is generally people coming to the end of their land management careers, not always, but often, and they will be saying, well, what am I actually going to leave behind? I'm going to disappear off this whenua, and what's going to be my mark that I leave behind? And they say, well, a good thing to do would be to protect this piece of land forever and make sure that bush stays there forever. So those are the kind of reasons. It's often a mixture of all three of those that drives people. So on to sort of opportunities and challenges in private land conservation, and I guess with a particular QE2 perspective on this. What makes it good first? So opportunities. What makes conservation kind of easy here is that they're generally small blocks. So apart from that 50,000 hectares, the average size, mean size is about 40 hectares. That's because 50,000 blows out the top end of it. But the median area is about 8 hectares, right? So that's something that's quite manageable for one person or one family to actually get in and take care of pest and weed control in there. So it's generally manageable chunks of land. Just to put that into perspective, that public conservation estate is about 8.5 million hectares, if you add up all the types of dock land. And I think DOC employs about 2,000 people, so you guys do the maths on that, and I think it comes out about 4,000 hectares each, which is pretty tough. So the people who live near those blocks, they tend to be pretty near where you live. They're often farming people. They've got a tractor, they've got a chainsaw, they've probably got a weed sprayer as well. So there's people there who kind of can get their hands dirty and do stuff, and they generally do. This model of conservation is extremely low cost to the public, basically because the private landowner does all the work. Social licence, I understand you guys have been talking about social licence. If the landowner says it's cool, then you can go and do it. I understand that life's getting pretty tough for science work on that public land. So this is a resource where, you know, if you want to try things out, you can certainly find out of those 4,500 landowners one who's going to be interested in the sort of thing you're interested in, and so you can get in there with their permission and do stuff. And the final point there is kind of linked to my one about rare and threatened habitats, is that you know, if we do actually want to restore some of the ecosystems from the lowlands and the coastal lands, these are the places that you're going to find the species and the genetics to be able to repopulate and restore some of that ecology. So those are kind of the good things. What makes it a bit hard? So those little blocks are kind of susceptible, is the first thing. So they're near to someone's garden, they're near to the farm, so bits and pieces that come out of gardens that are some of our key weeds, particularly in urban areas, are prevalent. They have a high edge ratio, so you know, when a storm or a flood comes along, you know, those little blocks can get wiped out. They've often or usually got livestock around them, so if the livestock aren't well constrained by way of fences, then they can get smashed pretty quickly. We do have cases where the landowner is either, you know, a bit past getting out in their covenant, or they've lost interest. So that can be pretty hard to address when people are kind of disengaged. And then finally, you know, particularly when we're talking about farmers, they got a lot else on their plate, right? So they're not focused primarily on conservation. They've got a lot of other stuff to worry about, including the sort of regulatory stuff that's coming down the pipeline pretty heavily at farmers at the moment. So they can become, you know, distracted. So how am I going for time? 7 minutes. So bioprotection, this is a bioprotection symposium, so I thought I'd better say something about this. What could you help us with on pests and weeds? Well, biologically, pest animals are kind of the same as what you guys probably all know about as ecological problems. Feral ungulates are a major problem all across the country at the moment, probably more so than they have been at any time in the past. We install, wherever we can nowadays, deer fences around covenants because the prevalence of goats and deer in the landscape is getting to the point where there's not much point just putting a normal 7-wire fence around things. Mustelids, you guys know those. Rodents, yep, those are tough. Marsupials, so increasingly, especially down this way, wallabies are a small but growing threat. Possums are everywhere. Wasps, that's on bioprotection. I'm thinking, you know, agriculture industry and conservation sector can all get behind a bioprotection for wasps, can't we? And I just put in very small writing at the bottom there, cats, because I don't want any hate mail. I forgot hedgehogs, sorry. Mrs. Tiddywinkle. Pest plants, there's nothing new here that you guys don't already know. Trees, so high country stuff, that mahu whenua, you know, There's some real challenges around wilding conifers. Nobody is surprised at that. Biocontrol for conifers, anybody? Sycamore is going to be the next thing. Willow in wetlands, blackberry in wetlands, etc., etc. There's lots and lots of these things. There's long lists. Every regional council has one of these lists. There's nothing new. Vines, so vines are a particular sort of ecological weed, not a pasture or production weed, but these things, particularly old man beard, ivy, moss plant, banana passion fruit, these get up over the top of native forest canopy and can cause a real problem. And then some more that you know about, shade tolerant shrubs or weeds, Tradescantia, wow, biocontrol, cool. Woolly nightshade, ginger, there's lots of those, there's a long list. So there's nothing really unusual about those. Diseases, microbes, so nothing unusual you guys haven't heard about those. Kauri dieback, myrtle rust are problems ecologically. So what's different? What's different about private land conservation that bioprotection people should think about? Hei tangata is the difference. It's the people who are in charge of those places and who are doing the conservation work that are different. So I know scientists struggle sometimes with people, but I think we need to think about this. So I've just highlighted a few of these things here. What's different in terms of the people aspects? There's limited public access to these places. So some covenants are open to public access free for all. Most are not. So particularly when you're in a production agriculture environment, farmers won't be that keen to have people traipsing across the land to get to the covenant to go for a little wander around. So they generally say public access with permission. So you can get in there and do things without fear of hurting the public is one interesting aspect for bioprotection. The landowners will get out in their tractor or on their quad with their sprayers and they will do stuff. They are a resource to be used and they're happy to do that without, I need to be careful what I say here, but they don't need to fill out 17 forms before they get on their quad bike. They will just go and do it. So in terms of that point about social licence, this is their land. If they think something's a good thing to do, they will do it. There doesn't need to be a whole lot of consultation with all and sundry. Some sort of, I don't want to say negatives, but some challenges around the people differences. So these are often farmers, but private landowners of one form or another. They are not connected to you in any way, as a general rule, right? They're not connected to the science system. They're not connected to government particularly. So I mentioned Tradescantia before, which is one weed where there has been good biocontrol research and action done. How many of my 4,500 covenanters have got access to Tradescantia biocontrol? Does anyone know the answer? I don't know. Not many of them. So a few of our regional reps get excited about that sort of thing. One of our guys was growing the trad beetle in his front room until his missus got really upset about that. So he was, distributing it around a few of his covenantors, but that was it, right? That's kind of an informal system. There's no connectivity between what you guys are doing and these people. So how do you create that connectivity? What's more, to the bottom point, how do you not only connect them but communicate with them in a way that lets them know that biocontrol is a good idea, is cost effective, is not going to cause them any other problems around the farm or anywhere else. So how do you form a conversation with those people? So I guess my challenge to you is think about the people in this whole exercise, and whether that be my history in the agriculture sector or my current role in the conservation sector is the challenges of research and what we call extension are people challenges by and large. So you guys can sit in your labs and do science all day, but unless there are people out there in the world who are going to pick that stuff up, have confidence in it and run with it, it's largely a waste of time. So how do you connect with my people, and how do you connect with, if you're working in the agriculture sector, how do you connect with those people? So I did put a slide at the end that says questions, but I don't think I'm allowed. No questions. No questions. We're doing questions in a panel later. That's me.
Oh, kia ora for that, and that whittle about he tangata, he tangata, he tangata. Yeah, kia ora, Dan, that was really good. We are going to leave the questions to the panel, but in the next session, the next kōrero from Aroha, we are going to allow questions because she's not here today, she's virtually here. So think about when, during her kōrero, that if you do want to ask a question or two or three, we will allow that at the end of Aroha's kōrero. So that's the only difference in today, because we are beaming Aroha in, and it gives me great privilege and pleasure and a blessing to welcome Aroha to the virtual room. And she is an amazing researcher. She's part of the Bioprotection Aotearoa whānau. She's also part of the senior leadership team of the Biological Heritage Science Challenge, where she co-leads the crazy and ambitious think tank. So stay tuned for those think tanks. And without further ado, I'd like to o mai te Pakapahi Aroha.
So first of all, I just need to do a bit of a sound check and image check. So can you hear me?
Yes.
Yes. And can you see my screen?
Aye.
Okay. Well, kia ora, and I'm really sorry that I'm not able to be there with you in person. My life just seems to be dominated with Zoom meetings, so I was really looking forward to some in-person time. I watched the YouTube recording of yesterday's speakers, and hopefully this talk can follow up some of the ideas that were expressed yesterday. So my talk traverses two notions. One is conservation, and the other is te mauri o te tai ao. Both are steeped in societal and cultural values, but they are not the same. One notion has dominated how nature has been treated here in Aotearoa and in other parts of the world, and the other has struggled to be recognised. One is part of the machinery of colonisation to express authority over both people and nature, and the other is part of the Māori worldview, to live within and alongside nature in a respectful way, acknowledging the modi or life force of all things, animate and inanimate. We have lived with a certain way of conceptualising conservation since settlers have arrived, and many of those values and assumptions went on to underpin New Zealand laws, regulations, policies and practices, including the Conservation Act. Passed in 1987, this Act has remained unchanged. And 34 years later, we have all the evidence we need to conclude that this approach to conserving and preserving nature, particularly indigenous flora and fauna, simply hasn't worked and isn't fit for the scale of threats to biodiversity and issues and aspirations we are facing now as we move towards a more sophisticated te tiriti o Waitangi nation and society. So in the year 2000, I received a telephone call that would change my life. No, I didn't win lotto. I'm still waiting for that. But I was asked to consider putting my name forward for appointment to the Governing Council of the International Union for Conservation of Nature, IUCN, with special responsibilities for Indigenous peoples globally. I knew a little bit about IUCN, but I knew a lot about conflicts between Indigenous peoples and conservation groups throughout the world, because these have been and continue to be a consistent negative experience for Indigenous peoples, a clash of values about caring for nature. And it's really quite ironic when you think about it. I decided to proceed with the nomination and subsequently was appointed to council for a 4-year term, followed by another 4-year term, followed by election as chair of one of IUCN's 6 Scientific and Technical Commissions, the Commission on Environment, Economic and Social Policy, and then followed by re-election for a second term as Commission Chair and fourth term on Council. So that's 16 years in what became a continuous deep dive learning into the history, values, practices, policies of conservation, and the move to acknowledge what hasn't worked and why, innovate and design new approaches and standards, and recognise the vital role that Indigenous peoples have in safeguarding the environment and offering solutions that have yet to be tried beyond our cultures. These photos are not as random as they might appear. They represent some of the meetings where significant turning points occurred in global conservation policies, and I'll speak a little more about these soon. So one of the highlights during my time with IUCN and as chair of CEAS was being able to convene in my hometown, Whakatane, a global conference, Sharing Power, named after the publication of the same name by leading Commission thinkers. Speakers included Ojibwe activist Winona LaDuke and Nobel laureate Eleanor Ostrom, which you see here in this photo. And it was at this meeting that a major shift occurred within IUCN in terms of acceptance that conservation not only needs social sciences, but that good conservation requires applied and social sciences to work together and alongside Indigenous knowledge and sciences. We took Eleanor to Te Urewera, hosted by Tame Iti. This was before Te Urewera was returned to Tūhoe. Ostrom's 8 design principles for managing the commons are often cited in New Zealand papers, and I think she'd turn in her grave if she read how her work is sometimes being quite perversely interpreted. Ostrom's principles, like the principles of Te Tiriti o Waitangi, are a total package of which governance in nested tiers from local level to the entire interconnected system is a central tenet. So as time is of the essence, these are just a selection of some of the shifts and innovations that occurred during my time with IUCN. I've already spoke of the shift of recognition that conservation is also a social science. This was a major intellectual change for IUCN, which is a science-based organisation, and it used to be quite sort of snobbish of the real science and social sciences. And, you know, it took evolution to work out that they really wasn't helpful, that if you want to galvanise around the protection of nature, you need all sciences on the table, you need all knowledge systems. The other shift, major shift during the time that I observed was that move away from a fortress approach to conservation of people, of nature without people, to something that's more inclusive, participatory conservation. And also recognition that in many parts of the world, protected areas were established at the cost of removing removing Indigenous peoples from their traditional territories, and that too often protected areas are governed in the absence of a system of shared objectives, values and principles. And at the 5th World Parks Congress, a new paradigm for protected areas was set, and following from that, a new governance category within the protected areas framework was established, and that's the IPCCAs, or Indigenous Peoples and Community Conserved Protected Areas. Having seen the success of the Red List, of endangered species, the people who were behind the red list of endangered species helped pull together with a new group of scientists to look at developing a red list of ecosystems. And I think the shift came from the same awareness that Travis talked about yesterday in terms of setting up this new bioprotection core and recognizing the need to shift from a purely species-centered approach to looking instead at ecosystems. So now there is a red list of ecosystems, but I guess they acknowledge that continuous negative messages of plotting the decline of species isn't how you mobilize people to get excited about conservation. And so a shift to more positive messaging, this notion of love, not loss, and being able to actually show positive change. So a green list of ecosystems was established alongside the red list. Acknowledging the vital role that Indigenous peoples play and how central Indigenous knowledge and sciences are to a lot of IUCN's work and conservation work in general. For the first time since IUCN was established in 1948, a new membership category was put in place, that's Indigenous Peoples Organisations, which means that IUCN will now be a member-based organisation of governments, NGOs and IPOs, Indigenous Peoples organisations. And that actually took my full 16 years on council to make that happen, to push it through. And then this notion of knowledge baskets, if I don't have the time to expand on it, but if you were to Google IUCN knowledge baskets, it will take you to a page where you will see right at the beginning the story of Tāne ascending the heavens to retrieve the 3 baskets of knowledge. And I brought this notion into IUCN to sort of shift from thinking of knowledge as a product, so they have knowledge products, and something to be commoditized, to more of a communal approach, of which a basket sort of resonates with people all around the world. And the main points that I want to make in these next few slides is that the same shift that I've referred to as happening within IUCN has been happening across a number of international processes. The global community has largely come to a convergence of recognizing the failure of unfettered capitalism and globalization and the devastating impact this value system has had on biodiversity and the state of the environment, suggesting that the world needs not just targets, but a whole new value system. And that of the targets that have been set through different processes, such as the Sustainable Development Goals, Aichi biodiversity targets, the Paris Climate Agreement, we're simply not meeting these targets. The Elizabeth Marema, the Executive Secretary of the UN Convention on Biological Diversity, made this statement recently that we failed the Aichi biodiversity targets because we assumed that implementation was the role of governments. She said we missed Indigenous peoples, local communities, youth, women. We missed the private sector, finance, business, and industry. And I was interested to hear the speaker before me because the private sector has an incredibly important role to play in conservation as we move away from a government-dominated system to a more inclusive system where everyone who is able to help and wants to help has a place at the table. But I think of the many international processes I've been directly involved with, IPBES, which is the Intergovernmental Platform on Biodiversity and Ecosystem Services, has, to my mind, really pushed the boundaries in terms of working towards recognition that the values and assumptions that sit behind this aging conservation system we're working with are but one approach of multiple options. And IPBES work in conceptualizing diverse values and valuations of nature is quite groundbreaking, and Indigenous and local knowledge is firmly anchored in all streams of its work. So the recently published global assessment on biodiversity made clear that biodiversity is on the decline in every country in the world, including here, and that the scale of decline has accelerated in the past 50 years, in other words, during our lifetimes and through our decisions and actions and inactions. The assessment identified drivers of biodiversity decline, but it also noted that nature is generally declining less rapidly in Indigenous peoples' land than in other lands, but is nevertheless declining, as is the knowledge of how to manage it. They made the observation that community-based conservation institutions and local governance regimes have often been effective, and at times even more effective than formally established protected areas in preventing habitat loss. So IPBES is currently happening now virtually. This has required me to log in from 10 p.m. to 2 a.m. every day. I've been participating in plenary sessions since 2011 as part of the IUCN delegation. And the hot topic of discussion right now is the difference between ecosystem services, nature's contributions to people, and nature-based solutions. So there's all these terms that have been kind of thought up in the past few years, and really interesting discussions about what they mean. I've taken you through a really quick review of some of the international work, but what I'd like to do now is to bring that all back here to Aotearoa. So with this background of knowledge of global landscape, I actually jumped at the opportunity to apply lessons learned to a review of New Zealand's conservation policies. I was nominated by Te Tira Whakamātaki, of which Nick Waipara, Amanda Black, and Melanie Shadbolt were the creators of Te Tira Whakamātaki. And the ODG, which is what I'll call it now, the Options Development Group, was tasked with undertaking a partial review of DOC's conservation general policy and the general policy on national parks to better reflect the principles of the Treaty of Waitangi. Not knowing what a partial review was, we opted for a full review, and noting that policies are designed to give effect to legislation, we also reviewed the legislation. The current legislation is incredibly outdated, some going back to 1953, the Wildlife Act, and conservation simply isn't working here at the scale that is needed. Our statistics make that abundantly clear, and our Indigenous flora and fauna in particularly is declining at an unprecedented rate, and much of that is happening within the DOC estate. So DOC's performance as a treaty partner has been heavily criticised by Hapu Iwi, but it's also found to be negligent by the courts, particularly relating to the Ngāi Tai Tamaki case. And that sat behind, I guess, the DG's decision to proceed with this review. So the Options Development Group made a series of recommendations covering legislation, policies and practices. Some require major reset of the conservation system, other recommendations can be implemented immediately as they are about the attitudes, values, and behaviours of DOC staff. So we loosely group the recommendations into these 7 areas. And what the ODG is recommending comes from a vision for a less Crown-centred, dominated and controlled conservation system to a Te Tiriti partnership model where Indigenous flora and fauna, Papatuanuku, are thriving. And what we've recommended is a wide review of conservation legislation to give effect to treaty principles, to reframe the definition and purpose of conservation to ensure it is fit for purpose for Aotearoa. The current definition could have been exported from North America. Also looking at centering tikanga and mātauranga within the conservation system. We're asking for a full review of conservation governance and management systems to better reflect treaty partnership at all levels. And this includes enabling devolution of powers to meaningfully recognise the role of tino rangatiratanga. And all of this, of course, can only happen with resourcing. So just breaking it down in a little bit more detail, in terms of legal reform, there are actually over 20 acts listed in Schedule 1 of the Conservation Act. So we're recommending a review of all of those acts. We're looking for a new definition and a new of conservation, and for the Conservation Act to be written as an act about conservation rather than the way that it's currently written, which is an act about transactions of regulating access of people to different aspects of the dog estate. As I've said, we want to see some key Māori concepts included in legislation and included in the policies. I want to see a reform of the Crown ownership model, public conservation lands, with the aim of, in some cases, returning lands back to iwi, not all lands, but some, and we're also reviewing the classifications of those lands. The big one is around repealing the Wildlife Act of 1953, which currently gives to the Crown full ownership of wildlife. And the way the Act is written, that also means that for, say, traditional weavers who use feathers from Indigenous birds, under the Act, the way it is written, the Crown theoretically owns those products of the weavers. So we're saying get rid of the Act, and in fact having ownership is really not the best way of encouraging people to come to the table to talk about how to protect. If you get rid of ownership in general and talk about shared visions and objectives, we think it will be a much more productive way forward. This will require reviewing and reforming all conservation entities, including the New Zealand Conservation Authority, conservation boards, and other statutory bodies to better reflect the treaty partnership and to devolve decision-making powers to tangata whenua. We're also suggesting that all of these things must be done as a package, not just picking off one or two things. And we're currently going around the country. We have over 40 hui with hapu iwi, as well as with the conservation boards, where we are sharing the recommendations and getting feedback. I just want to summarize, and by summarizing by saying, you know, that conservation as we are doing it now isn't working. It's not working in Aotearoa. It's not working in any other part of the world where this type of conservation is the major paradigm. and that at the same time, the scale of problems and threats to biodiversity is increasing, and that there is a recognition that we need a radical change. People will often speak of it, and politicians will speak of needing radical change, but they're actually reluctant to go to that next step of implementing a radical change. So the Options Development Group sort of provides a template for how the conservation system can be reformed. And we think that it's absolutely critical that it is reformed. It's critical for nature, as well as critical for the Māori Crown Treaty Partnership. And through all of this is really moving away from the nature without people value system to a full integration of people living in harmony with nature, respectful of the life force of all beings, and to design a new pathway forward on that basis. So kia ora, that's my talk. Happy to answer any queries that you might have, and I hope that some of what I said is of interest and relevance to you. Kia ora.
Kia ora aroha, we're truly blessed with that kōrero, but also your amazing mahi over the, as you said, 16 years and more. And with that has produced huge changes and system changes, and radical shifts are now needed. So kia ora aroha, and thank you for joining us. So questions. We are going to delay so that we can honour Aroha with a question or two for her kōrero today. We've got one. Oh, we've got this cube thing. We throw it up. I don't trust my phone.
That's terrifying. Kia ora, Aroha. That was fascinating and really, really thought-provoking. Thank you so much for your contribution. Oh, I'm sorry. I'm Julie DeLippe from Victoria University in Wellington. I'm wondering if you see any evidence of a co-management strategy that protects Te Māori o Te Tau functioning now in New Zealand. Are there anywhere where this is working and where we could look to these places to guide us towards better conservation?
I was having trouble hearing, but so let me just say what I thought you were asking. You're asking if I could share with you some examples of where a Te Māori or Te Taiao approach is working. Is that what you're saying?
Yes.
Yeah. So first of all, I'm using the word Māori, but it could be oranga, which is well-being. It could be mana, which is giving authority to the environment. The main notion is that you start taking care of nature by respecting it, not from a place of trying to dominate it. Where it has worked is the successful, well, ironically, we're going through this national discussion now about SNAs, significant national areas, and how a significant portion of the remaining indigenous forests actually exist on Māori land. And that's because Māori many Māori landowners have refused, in spite of many incentives, including financial incentives, at various times in the past 50 years, to clear fell them and designate the land for farming. So I think you can start at that level and just say that for the land that Māori have been able to hold on to through the process of colonisation, many key biodiversity areas actually sit within those lands, and that's not by accident. That's by deliberate exercise of kaitiakitanga over those lands, we're saying that, and consistent with what the Waitangi Tribunal in its report, Ko Aotearoa Tēnei, on the Y262 Indigenous Flora and Fauna claim said that for the well-being of the people, there has to be a direct connection to all the species, to the ecosystems that live within the traditional territories of that people. And that we could sustain maybe 2 generations of being separated. We're at the 3rd generation right now. So this is a critical time for the reconnection of iwi back to ancestral territories in order to hold on to that knowledge system that has so wonderfully been able to keep as much of the environment in a good place as possible under pretty difficult circumstances.
One more. Oh.
Is that right?
My working off dessert.
Kia ora, Margaret Stanley from University of Auckland. I guess I'm looking for a bit of hope, Araha. I just wondered if you could comment on whether you think this reform will move at glacial speeds or at all, or do you think we will be able to make progress in this area?
Nick, maybe you're able to tell me the last part of the question. I got that you wanted to see some hope.
Yeah,
I'm sorry, I missed what you were saying before that.
Yeah,
but
just the speed.
Responding to that comment, the wonderful thing about nature is that if given a chance, we've seen that nature can come back, species can come back, ecosystems can be restored with a little bit of help. And I just can see, and particularly when you scale up to the global level, that we've only been approaching the preservation of species through a very narrow lens. Imagine the possibilities when you bring to the table multiple value systems, multiple options, and you don't discount them because they don't happen to be the same as the dominant value system in conservation. I'm actually filled with hope. I don't think we're going to continue to go on a decline. I think if we make the shifts that are needed, not only will nature do better, but we'll do better, because we're not doing that well as a people either, or as a country. So we can certainly showcase a very different type of conservation here, and reflect sort of some of the amazing things that are happening overseas. I'd just like to share with you, so a country like Ecuador, so here in New Zealand, we have 33% of our landmass is taken care of by DOC. DOC has never had nor will ever have the human or financial resources to proactively manage that scale of land. And we can show to the world that numbers, targets in themselves aren't enough, because the world is trying to get to a 13% target of protected areas landmass. And we've had more than that for a long time, but we're still experiencing the same scale of decline as other countries. So we can really turn that around, but it does require the Crown to consider letting go, consider seeing conservation as a people issue for where everyone has a role, and just radically redesigning conservation to take into account the millions of volunteers that operate already out there in wider New Zealand on conservation projects every single day. That they're invisible in our accounting of conservation success or failure, and a system redesign can help bring visibility to their efforts.
Ti hei mauri ora. Kia ora, Aotearoa. Homai te whakatau. That was a true blessing to hear you today, Aotearoa, and we are, as a whānau in Bioprotection Aotearoa, truly humbled and blessed for your mahi, your mātauranga, and your presence today. So kia ora. It gives me great privilege today to also welcome Lauren Waller, now postdoc, mahi across Project 6 and 7, and has done a wonderful amount of research and mahi herself here in the Bioprotection Research Centre core. So I'm really pleased that you're here today to give you an overview of some of your research and mahi. And welcome, no mai, haere mai.
Kia ora koutou. Thank you, Nick. Well, these species are probably familiar to everyone in the room. They represent some of the worst and some of the most ubiquitous invasive weeds in the country. They were all introduced here intentionally from faraway places. And they present a big conservation threat, but they also form the backbone of the country's agricultural and forestry sectors. So ironically, we want these species to succeed, but we don't want them to be too successful. So, there we go. And sometimes, as we know, they do become too successful, and they escape their intended boundaries. And we think this might be because they've come from this other place where they were kept in check by natural enemies. And they've come to this new place where potentially those enemies don't occur, or they have less impact on these species. And this is the whole idea behind biocontrol, right? So when these species become very successful, we go back to the species' home country, we get these enemies, we bring them back to control them. It sounds pretty crazy, doesn't it? But biocontrol and the success of biocontrol really does, it's evidence for the importance of biotic interactions in shaping invasive species success and impacts. And so that's what I'm going to talk about today, is how invasive species success is mediated by interactions with other organisms. And first, I just want to say big thanks to so many people and acknowledge all the wonderful folks who have helped out here. On the top, we've got our PIs, postdocs, and students on the right there, and loads of other people. And I could spend about 15 more minutes just showing you faces of people who've helped, and actually large equipment and machinery that helps with all the research that I'm going to show you today. But in the interest of time, I'll just say that the work I'm going to show you is the result of many, many helping hands and minds. So the first project I'll talk about is Project 6, Achieving Bioprotection in New Zealand Ecosystems. So we set up a large multifactorial experiment to explore how interactions between specifically invertebrate herbivores and soil biota affect invasive species success. That's my partner there, Warwick Allen, who did all this work with me. So I'll just tell you a little bit about the design of this experiment. There's kind of a lot to take in. So what we did is we created and designed these 20 unique little mini ecosystems, little mesocosms. These communities, they varied in their proportion of exotic species, ranging from 0 to 100%, with some mixtures in between, and their proportion of woody species, from 0 to 60%. Each community was made up of 8 species, and they were chosen from a pool of 39 native and exotic species, all that co-occur, particularly in the Canterbury region. So I told you that we did these manipulations of the soil biota and the herbivore communities. To manipulate the soil biota, we went out into the field and we collected truckloads of soil from places where all of these species occurred. We mixed up all that soil, we brought it back to the greenhouse, and we grew plants in those soils for about a year to culture the specific microbial communities that would typically associate with all of those species. After about a year, we harvested them, we retained all that soil, and we made up these soil mixtures to put out into our pots in the field. So we had what we called home soils and away soils. A home soil would consist of all of the soils from the species that were grown in a specific community. So presumably would contain the generalists and specialists, enemies of those plants. An away soil would consist of 8 soils from 8 species that did not occur in those communities, and presumably only occurred the generalist enemies. Warwick, the insect whisperer, was in charge of the herbivore additions, and he went out into the field and collected loads of insects. He also, I think, got some from some people in this room. He reared them in the lab, and he introduced them to all of these mesocosms. So you're probably wondering why they all look like ghosts. Those are mesh cages that are around each of the those pots, those plant communities, and those are meant to keep those herbivores either in or out. In all, he was able to get 20 herbivores established. These were a mix of exotic and native species. There were some agricultural pests. They were mostly generalists, and they had a range of feeding styles. There were root, stem, leaf chewers, suckers, and miners. And Warwick did a number of surveys through the extent of the experiment, and he extrapolated biomass estimates and things like that. So we let these communities grow for about a year, and then we harvested them. And one thing that was very apparent is that the exotic plants had very, very big impacts. This is just one of the communities that we have where you see these 2 giant exotic plants, and there's a tussock grass that's literally hanging on for dear life. I think it's trying to escape from the pot there. And so we found this across the board. Exotic plants were very big compared to the native plants. This is just a graph showing you the above biomass in those pots. They were quite large. They were also quite competitive. Sorry about the graph is looking a little bit funny. I'm a Mac user. Enough said. And so as you can see, this is just a graph showing you how the richness in these pots declined in these exotic pots. And please take a second to get used to this, the format of this graph, because a lot of the graphs will look like this. On the x-axis, we have the proportion of exotic plants ranging from 0, so our native communities on the left, all the way to 100% exotic to the right there. On the y-axis, we have our response variable here. It's just the number of species that were in the pots at the end of the experiment. And as you can see, in these native-dominated communities, we started with 8 species, and we often finished with 8 species. But as you add invaders, you see that richness really declines quite sharply. So they were very competitive, even among themselves. So there were some differences among invaders in their competitive ability as well. So exotic plants had big impacts in communities. They were very large. They were strong competitors. So far, not a lot of surprises, right? But the way that we designed this experiment really allowed us to tease apart the effects of biotic interactions on these impacts. And so that's what I'm going to tell you about. But first, I'll just talk about some of our hypotheses. So there are a number of scenarios that could happen here. We might expect that exotics make weaker interactions with insect herbivores and soil biota, in which case then the natives would be harmed to a greater extent than the exotics, and then we'd hypothesize that exotic plants can outcompete the natives in those communities. Alternatively, we may see indirect effects where the exotics make stronger interactions with enemies. Those enemies accumulate, and then they spill over onto the natives, giving the exotics another advantage, and they may, in this case, also be able to outcompete the natives. So we were able to test these hypotheses with this design, and I'll tell you about that starting with the herbivores first. So exotic plants did make stronger interactions with invertebrate herbivores. Again, this is that same format of the graph here. We see that herbivore species richness increased along our exotic gradient. There were more herbivores, and there was a greater biomass of herbivores in these communities. But did this translate into increased competitive ability? Well, not really. So on this graph here on the left is showing you, again, the same graph I showed you earlier, native and exotic plant biomass. We still see that exotic plants are larger in these plots. Even though they're accumulating all of these herbivores and these herbivores are doing damage, they're still much larger. But what this graph shows you is this difference with the herbivore treatment. So you can see that herbivores had no effect on native biomass, but they did have a strong effect on the exotic plant biomass. So there's a 30% reduction in their biomass in those herbivore plots, but they still were incredible competitors, as you can see here in this graph on the right. So what you're looking at is you can see these dotted lines, and that's just the proportion that proportion of biomass that we planted these plants into in the community when we started. So as you can see, there's 25%, 50%, and 75%. And the dots that you see above that, that's our finishing biomass in these pots. So the exotic plants did really, really well. They took up a much greater proportion of biomass in these pots, despite the fact that they made these really strong interactions and were quite damaged by herbivores. So exotics did make stronger interactions with herbivores compared with natives, but these enemies did not spill over onto the natives, and it didn't. These stronger negative interactions did not reduce their competitive ability in these plots. But so how did they do it? How were these exotic plants still so competitive? Well, another thing that we found is that there was higher herbivore biomass in communities that had exotic plants with high specific leaf area. This is a trait that's associated with faster growth, higher tolerance to herbivores. So it suggests that maybe there's a trait explanation for this, for what we saw, that maybe these plants are just able to grow a lot faster despite this herbivore pressure. So next, I'll tell you about the soil biota and what we found there. So remember, we grew these plants in home and away soil. And what we saw is a big effect of our home soil treatment on these plants. So when plants were grown with specialist and generalist enemies, presumably, their biomass decreased quite a bit, as opposed to these away soils where they did quite a bit better. But there was no effect of plant provenance. So natives and exotics were both harmed to a similar extent by our soil treatment, that home soil treatment. But you can really only say so much about these kinds of results. These are plants that are grown in bulk soil. The effects that we're seeing, they could be due to pathogens in those soils. They could be due to poor mutualists or any number of things. So another thing that we did to try to tease apart the effects of soil biota is we did barcoding. We sequenced all of the fungal communities in these plant roots, all 1,152 of the roots. We then used taxonomic functional databases to assign function to our sequences. And then we also measured PLFAs and NLFAs to measure the fungal and bacterial biomass in the soils. And so, another funky graph, sorry. So what we found was we saw that pathogen abundance increased along our exotic gradient. So again, here's this. We're looking at these communities. As you increase exotic dominance, we see this increase in relative pathogen abundance in those communities. And we also saw a sharp decrease in mutualistic fungi in these exotic dominated plots. So they're making stronger interactions with enemies, once again, in the soil. But again, and also, if we look at the plant, at the individual plant level, we also saw that exotic plants supported more pathogens, more sequences in their roots that were pathogenic to these plants. But did this translate to reduced competitive ability by the exotics? No, the exotics, this is the same graph I showed you before. Exotic plants were really big. Again, in spite of the fact that they're accumulating all of these pathogens, they're still quite competitive and quite large. So to try to understand how the soil biota might be driving some of these effects, what we did is we looked at the proportion of pathogens that were shared in each of these communities between natives and exotics. So if you have a given community, we looked at how many pathogens were associating just with natives, just with exotics, or shared between the two. And what we found is that there was quite a bit of sharing of pathogens. Now, this is a really ugly graph, so I'm just going to walk you through it slowly. So what we're looking at here is how the proportion of shared pathogens changed along this exotic plant gradient. So you see it's a hump shape, and it's a hump shape because we're at 0 and 100% exotics, right? We can't be sharing any pathogens. But as you increase the number of exotic plants in the community, you see an increase in the proportion of shared pathogens. But what's interesting about this graph is if you focus on that gray band there, what that is it's a simulated null model. It's telling us the sharing that would occur by chance if natives and exotics were completely equivalent in their ability to share pathogens. So we ran that model 1,000 times, and we came up with this gray bar. And so what's interesting is that when you look at the real data over this, you can see that our black line in the native-dominated plots is below that null model expectation, where in the exotic-dominated plots, it peaks and it comes up over. So what it's telling us is that these exotic plants are more likely to share pathogens than you would expect by chance, where the natives are less likely. So these natives appear to be more specialized in their interactions, and these exotic plants tend to be more generalized. So finally, the last graph I'll show you from this project here is we're trying to figure out whether or not there's any correlation between pathogen sharing and plant success. So we use this equation here, the relative interaction intensity index, which is just gives us an indication of competitive ability. So any of the dots that you're going to see in that blue area above the 0 line indicates stronger competitive ability by natives. Anything below that 0 line in the peach indicates a stronger competitive ability by exotic plants. And so if we look at that and we look at this compared to the proportion of shared pathogens, what we see is if you look at about 30% of shared pathogens there, that's where that line is. That's where natives are always doing worse. So we have some variation in competitive ability in these different plots, but it really declines once you are sharing about 30% of the pathogens, and in that case, exotics win every time. So this just suggests that there's some correlation between pathogen sharing and this plant competitive ability. So just to summarize the results from this project, exotic plants had strong impacts on native plants, unsurprising. Exotic plants supported more herbivores, more fungal pathogens, fewer mutualistic fungi. Exotic plants were more successful in spite of this, in spite of the high herbivore and pathogen loads. And exotic plants shared pathogens with natives, which did correlate with exotic plant success in these communities. And so now I'm going to tell you a little bit about Project 7, some of the work that's been done in that space, looking at whether fragmented kauri ecosystems facilitate pathogen spread. And we know that kauri is in real danger. Its habitat has been shrinking to under 1% of what it was once. Particularly now, it's under threat by the pathogen Phytophthora agathodicida. So I showed you in the last project that we saw these big changes in fungal communities, right, when we increase the proportion of exotic plants that are in a community. Well, Alexa Byers, who is a recent graduate of BPRC, she looked at fungal communities in kauri and in pine plantation soils, and she found a similar result. She found that fungal communities were quite different in these two different land use types, indicating that there may be some functional consequences of these changes in these forests as well. And then Kai Lewis, another graduate of BPRC, he did a soil assay, and he looked at the potential for reproduction of this pathogen in soils from kauri soils and from pasture and from pine soils. And what he found is greater reproduction in these exotic soils, again, suggesting that there is some reservoir potential in these exotic-dominated areas for the pathogen, for Phytophthora agathodicida. And then the very last thing that I'll show you is some work that I just did with the help of Alana Thurston, looking at the degree to which phylogeny or plant provenance can predict the inoculum potential of different species. So what you're looking at here is a phylogeny of 108 species that I tested. You don't need to look at the species names, but the red ones are exotics and the black ones are the natives. And these bars here indicate pathogen growth on leaves. I did a detached leaf assay, so put a little bit of inoculum on each of the leaves. I measured the growth of the pathogen on those leaves. And we found that exotic plants, the pathogen grew, Phytophthora grew faster, and the lesions were larger on these exotic leaves. So this may be good news for the natives, but it's pretty bad news considering these exotic plants may be strong reservoirs for this pathogen, which is terrible news for Kauri. And so just to summarize both of these projects, invasive plants may be important reservoirs for pests in Aotearoa, New Zealand. And the ability of exotic plants to tolerate pests and share them with natives may increase their competitive ability and their threat to conservation. And so with that, again, even more thanks to more people. And thank you so much for listening.
Kia ora, Lauren. That was amazing and an outstanding summary of the last few years that's gone on here. So without further ado, we'll break for morning tea. Hold the questions for Lauren and for Dan to the panel, and go and get your coffee. Kia ora. Oh, kia ora, welcome back. Just to, there's a few people that if you have to return to Auckland by a certain time tonight, please get in touch with those who shall be obeyed outside. But apart from everyone else, welcome back. Just reiterating, we're having the questions after our wonderful next speaker, which is Julie Dillip, all the way from Wellington. Yes, another one. Welcome, and it's really exciting because Julie is one of the new research leaders in Bioprotection Aotearoa, so it's fantastic to have you here, and we're going to hang on every word you say. So welcome. Nau mai haere mai.
Kia ora, and tēnā koutou katoa. Ko te where e tu mai nei, Lincoln University, home of bioprotection, tēnā koe. Ko ngā tainata whenua o konei, tēnā koutou katoa. I wanted to begin by acknowledging the excellent work in plant protection that has come out of the Bioprotection Research Center, which has brought us here today, and also the work of the many leaders in this room, Matua Henare and John and your teams and our science leaders that have welcomed me so wholeheartedly into this community of researchers. So as Nick said, I'm not in the BPRC, I'm new to the BA, and so I'm not going to be able to tell you about all the cool work I've done in this context like Lauren just did, but I'm going to build on some of the things said earlier today by Dan particularly, and I hope that you'll see, I hope I'll convince you that I should be here. Let's put it that way. Okay. That's right. Okay, so my name is Julie Dillip. I'm a plant ecologist at Te Harangia Waka, Victoria University of Wellington in the School of Biological Sciences, and I'm also the Deputy Director of the Center for Biodiversity and Restoration Ecology there. And my group works on plants and microbes and how their interactions determine the stability of ecosystems in certain states. I'm particularly interested in how those states are maintained in the face of global agents of change. So things like emerging pests, emerging disease, and my favorite topic, climate change. So we do work in lots of different ecosystems. I have a large program, or large by my standards anyway, working in Tongariro National Park and the Tuwharetoa and Ngāti Rangirohe on alpine ecosystem change. I work a lot in the Wairarapa Valley on restoration of wetland forests, and that's what most of this talk will be about. And I have a small program, kind of new and starting, in looking at co-planting strategies to combat Phytophthora agathodicida in kauri forests. But today I'm going to talk about wetlands because they're super important ecosystems. As you all know, they're hotspots for biodiversity, and we're in a biodiversity crisis globally right now. They're also hotspots for many ecosystem services or nature's benefits to people, right? They purify water, they sequester a large quantity of carbon. They're very, very important at protecting our homes from things like floods. They're also sources of mahinga kai and whatu, and important places for recreation and well-being generally, especially spiritual well-being in many, many cultures. But wetlands are in peril. Globally, we've lost 64% of wetlands, and New Zealand is well and truly above this mean value at a whopping 90% of wetlands lost. And where I'm from, in the Wellington region, in the Wairarapa Valley particularly, this value is as high as 98%. This is a major process through which they're lost, where we take swamp forests, forested wetlands, and turn them into productive agriculture systems. This is a map of the Ruamahanga Basin. So this is the Ruamahanga River. This is where I am in the world. So here's Wellington, and here's the Wairarapa Valley, which consists of the river basin. And this is the former extent, so pre-development, pre-human development. I should start by saying that the Wairarapa was one of the first places in New Zealand colonized by people. So when Maori arrived in the country, there were large settlements already at the time of European arrival. And this was everything Dan said: low-lying, fertile, receiving areas of the landscape that were easily converted to agriculture. So these wetlands that are in this kind of icky, browny, gray color have been lost. And this is the dark green area, the contemporary, these little dots that are almost invisible, are the current extent of wetlands in the Wairarapa Valley. They are fragmented. They are very, very small. So most are under 3 hectares. And they are under private ownership, which is why I was so grateful to Dan to do this wonderful introduction to this topic this morning. So 75% of remaining wetlands in the Ruamahanga Basin are on private property. They're farms, right? So this brings me to a project that I've been involved with for the last about 3 years called Wetlands for People and Place. And what WPP, as we call it, is about is research to facilitate more wetland restoration and more effective wetland restoration to improve biodiversity outcomes and nature's benefits to people in the Wairarapa Valley. So if you're going to start a project like this, if you're going to try and figure out how to restore wetlands more effectively and get more of this happening, the first thing you need to do is try and figure out what's been lost, right? Or that's what we thought we should do first. So we asked the question, what are the consequences of wetland loss in the Ruamahanga Basin? And to answer this question, we used a landscape model called the Land Utilization and Capability Indicator, LUCI. We don't yet have t-shirts that say, I love Lucy, but I keep threatening to make them. And this model takes a bunch of digital inputs, so it takes elevation, climate, land cover, and soils, and it models different outputs. And these outputs are typical ecosystem services, if you will. They're things like agricultural productivity, flood mitigation, sediment retention, and nitrogen and phosphorus, so nutrient retention. Okay, so what we did was we modeled the Ruamahanga Valley with current land use and land cover, so as it is now, and as it would be if those wetlands were intact. And what we found is probably not surprising to you that increased agricultural productivity is a major outcome of land use change, right? But it comes at a cost. It comes at the expense of flood protection. We saw major losses. These are, in purples here, are all the losses. Grays are kind of neutral zones, and greens are gains. So we get these gains in agricultural productivity. But it comes at the cost of flood protection and a loss of nitrogen and phosphorus retention in those ecosystems. We looked at what portion of the landscape contributed to these outcomes. So this is the percent of historical wetland area. And these are the net changes in those different ecosystem services. And you can see that on a whole here, what is this, 67% of the land area had negative ecosystem service outcomes. But there are some variations. Some of these changes led to positive outcomes for ecosystem services. So we were interested in this variation, and we looked at it at high spatial resolution. And what we found is, wetlands are spatially complex. And if you consider what they were converted to, the vast majority of the landscape has been converted to pasture. And on a whole, these were neutral or net negative changes. But a few of these systems were, wetlands were converted to other land uses, such as broadleaf indigenous hardwood forests or gorse and broom covered landscapes, for example. And those wooded ecosystem types tended to be associated with gains in ecosystem services. So trees are good for ecosystem services. It's probably not a result that's surprising to you, but I want you to bear it in mind because it becomes important. Okay. The other thing we were interested in looking at is how the initial condition of the wetlands affects the changes in ecosystem services. And so we compared fens. So fens are herbaceous wetlands. They're wetlands without trees, so they're dominated by things like toitoi and harakiki. And compared that to swamp forests, typically dominated by kahikatea, swamp swamp mare or swamp manuka, for example. Pukatea is another dominant in the system. So these swamp forests were associated with the largest losses of ecosystem services. So when you remove trees from a wetland ecosystem, you're going to lose more ecosystem services than if you have a herbaceous wetland that you're managing under pasture. And that was felt right too. Okay, so now we have some idea of where the wetlands were, what they are now, and how changing them has become problematic in terms of nature's benefits to people. But of course, you all know that this is a conservation section of the talk, and restoration is going to be key to gaining conservation outcomes in the future, okay? It's definitely got to be key to management of wetlands in this country into the future. And there's growing momentum in this area. There are now over 30 not-for-profit organizations in this country that are actively engaged in restoring wetlands. So this is great. This is an awesome time to be involved in wetland restoration research because people want this now. But it kind of begs the question. So given that 75% of wetlands in this region are under private ownership, and they're small and they're fragmented, we wanted to understand where and how people are restoring wetlands on their property. So we asked them. It's actually a really hard bit of information to get. Where are restored wetlands? You figured you could Google map that, right? I did, naively, when we started this. I thought, oh, well, there'll be a registry somewhere. We'll just figure out where, we'll go to QE2 and they'll tell us where all the restored wetlands are. And surely the regional councils have that information, right? They do, but they won't share it. We really actually had to go out and do snowball sampling of like-minded farmers. And this is, I just want to echo what Dan said earlier, is that like these coalitions of the willing, of people who care about what you do, are willing to engage with you and will tell their neighbor, are such powerful, powerful partners for us as an organization. And where these people are willing to work with you, I've just found it enormously rewarding. So like as a scientist, I'd encourage you to give it a go. All right, so we asked them, and this is the work of my amazing postdoc, Dr. Stephanie Tumshaw. She went out and interviewed these farmers, and she said, what have you done to restore your land, right? And there were lots of things they did, I think over 22 different treatments, distinguishable treatments. But by far and away, what people do is they fence to keep the stock out of the wetlands, and they plant some native species, often woody species. So remember those two things. We then wanted to kind of assess the consequences of wetland restoration in these private areas, okay? And to do that, we had to map them, okay? So Stephanie undertook this participatory mapping exercise where she sat with the farmer and she had a tablet and she mapped out where their wetland restoration project was on their farm. And that allowed us to predict some things about it in terms of where it was on the landscape and that kind of stuff. And then she asked them a bunch of questions about their values around their restoration. Okay, why did they do this? What values, what benefits do they derive from having a restored wetland on their property? Once we had the maps, we could run our Lucy model again and generate those ecosystem services I just told you about. I won't go through all that because I don't have time. But we were also able to go back and work with those farmers on their private land and take some field measurements. So we were able to do standard vegetation plots and some soil sampling. And we asked each farmer a question: where on your property does this wetland reflect in an unmanaged state? So if you were not restoring this wetland, could you show us a plot of land that would be similar, right? And so in 99% of the cases, they were like, oh, well, just the other side of the fence, right? Yeah, this is the restored wetland, this is the boggy paddock I haven't restored, right? And so we used a paired sampling approach to kind of assess the gains in ecosystem services through restoration. So I'll show you a bit about that data now. Firstly, starting with the human values. So overall, the farmers we interviewed varied most dramatically in the number of values that they recognize from their wetlands. The major axis of variation kind of separated these tangible values from these intangible values. So tangible values included things like agricultural production during the dry season, right? Hunting, fishing, swimming, boating, those sorts of things. And those separated quite strongly from these intangible values that had to do with relaxation and aesthetics, maybe heritage of the area, and some notion of biodiversity, that big word, right? And these kind of values were strongest in the data set, but there was also a second axis of variation, which kind of we thought might reflect kind of ideas of collective values versus individual values. So there were some individual values that were like, I like to go there and paint, I do artwork there, this location has particular family memories to me, or I keep bees and they like that place because it has lots of manuka flower, those sorts of values, as opposed to kind of more collective things like I want to maintain access for trampers, or this is an educational opportunity for the local school, or I restored this wetland because it's important for preventing erosion or fertilizer runoff at larger landscape scales, so kind of collective benefits. Okay? We also ran that model again, and we modeled how these restored wetlands impacted things like nitrogen export to waterways, phosphorus export, and sediment export. And we found that even these very small restorations, so most of them were less than 3 hectares, created significant gains in nitrogen and phosphorus export, but didn't significantly impact sediment emissions. We also looked at soil indicators of ecosystem health, so things like soil organic carbon, saturated hydrologic connectivity, which is the soil's ability to mitigate flood, and things like native species richness had large and significant gains with restoration, and things like Olsen P, so plant available phosphorus in soil was reduced in these restored wetlands, suggesting that the plants planted took up the phosphorus. So those were good signs. Next, we had the wonderful Shannon Betley, who just finished an MSc in my lab and also whakapapas to the Ruamahanga Basin. And she looked at microbial indicators of soil health. And the story here was really interesting to me. She found that on a whole, restoration increased microbial biomass, but this was associated with no change in bacterial biomass. It was all driven by fungi, and in particular, the arbuscular mycorrhizal fungi. So this led to large and significant increases in the fungal to bacterial ratio, and also the aerobic to anaerobic microbial ratio in these soils. But location mattered a lot. So these changes were greatest at upslope locations, and there was no significant change in many cases near the water's edge. And this again is that effect of trees, these highly variable outcomes that come when you plant woody vegetation. They dry out the soil, they increase the AMF load, and we're seeing, you know, quite some ecosystem succession in some of these restored wetlands. Okay. So Shannon drew this beautiful photo, she's awesome, and she summarized the biophysical consequences of wetland restoration in these wetlands. And so on a whole, what she saw was wetter soils with higher organic carbon and a higher microbial biomass, which was dominated by fungi. This was associated with increasing saturated hydrologic connectivity, the KS there, and reduced phosphorus loads. And she interpreted this in terms of an ecosystem services lens to reflect greater water purification, we saw that in the nutrient data, greater carbon sequestration in the form of plant biomass and microbial biomass, increased flood abatement from the saturated hydrologic connectivity and the soil organic carbon, and increased biodiversity of native plant species. So all excellent outcomes on these very small, potentially seemingly insignificant restoration blocks. Okay. A big finding of Shannon's results was the variation in these restored blocks. What we found is a wet boggy paddock is a wet boggy paddock, no matter how you measure it. But when you restore it, you get a whole variety of outcomes. And so we were very interested in that variability. What's driving this variability in wetland restoration outcomes? And so, mind you, she was only able to do the full analysis on 18 farms, so this is a relatively small data set. But she looked at these treatments that were applied and something about the landscape context of these restoration treatments, and did some cluster analysis, and she found that the greatest increases in biophysical indicators of ecosystem health, so good things we want these ecosystems to do, were associated with the flowing wetlands, with large catchment areas, so wetland restorations that took place in a large receiving area, and where they were planted with native trees. So those were interesting observations, albeit a small sample size. Okay, so shifting gears for a second now away from the soil properties and looking at some of the other biodiversity benefits that these small fragments of restored wetlands may provide to our ecosystems. We had a small student project done by Rosie Bradshaw, and she looked at the role of these small wetlands in connecting to the remnant wetlands used by the critically endangered Australasian bittern, okay? And she found that they like to fly between them, and they would sometimes stop off at these wetlands. So their preferred pathways were always within a 100-kilometer radius of these larger habitat areas like Lake Wailapa down here. But they would use these little restored wetlands in some cases to kind of jump between. Okay, now I'm going to shift gears again and talk about another kind of biodiversity loss that's heavily influenced by land use change, and that's the loss of forests. So you all know that Aotearoa, New Zealand was once a very, very forested nation. And that over the last few hundred years, we've rapidly deforested the landscape. And that this is an unequal loss because, as was said earlier today, we're not really losing beach forests at the same rate that we're losing these lowland fertile ecosystems. So there's been a disproportionate loss of wetland forests, and the remaining wetland forests are highly fragmented. And this is a conservation concern because wetland forests are likely to experience significant genetic erosion as a result of this fragmentation, okay? So many wetland forest fragments now look like this. You know, they have stock walking through them, eating all the seedlings. They're disconnected. This might be a pine plantation. It's not in this photo, but it could be a pine plantation. There's no gene flow between these landscapes. And this is a particular concern because the genetic structure of most tree species in this country is not well understood, with the exception of maybe manuka. We're working on kauri, right? We don't know a lot about tree genetics in this country. So it makes it really hard to develop restoration plans that are going to sustain these species into the future. We also, of course, have many emerging threats, and it seems like there's a new one every few years, right? So we all know that myrtle rust is here since 2017, and that we have many important economically, ecologically, and culturally important Myrtaceae species in our forests. And the susceptibility of these trees or these plants to myrtle rust is not known for many of the species, but doesn't look good so far, right? Wherever we think, we're just finding more and more species all the time that are hosting the pathogen. And so this brings me to the work of my PhD student, Colin Balkwell. And this is in early stages, so I'm not going to be able to show you any data yet. He's just assembled the genome of Mare tawake, so swamp mare, Sagissium mare, to create restoration genetics scenarios for this species, essentially a recovery plan for swamp mare. Now, we chose swamp mare because it's nationally critical, it's Myrtaceae, it hosts the pathogen, and it is already very, very fragmented. It has always been, by virtue of its ecology, a habitat specialist, right? It likes lowland forests. It will have disjunct populations by virtue of its own evolutionary trajectory. But we fragmented its habitat so extremely that it's very, very likely to be at risk of genetic erosion. So we're interested in looking at that. The aim of his PhD is to characterize the extant and ancestral population structure of the species and to look at the effects of current modern habitat fragmentation on landscape level processes, so things like dispersal and pollination and those sorts of things. So it's a bird dispersed. It's got a big yummy berry, bird dispersed species, and mostly wind pollinated plant. Yeah, and so ultimately we'd like to enhance the restoration planning that we're doing with something that accounts for an umbrella species of swamp forests. So using swamp mare as an umbrella species for other species conservation. Okay, so that brings me, I hope I haven't run out of time, to what I'm going to do in the Bioprotection Aotearoa core. So really we want to kind of merge some of this work and take it a couple steps further. We're interested in understanding the spatial dynamics of emerging threats to ecosystem health. We're particularly interested in looking at the interaction between landscapes like this, so manuka, kanuka, honey industries, and how young, early successional restoration projects are often dominated by these species. And also things like Feijoa growing. These are all members of the Myrtaceae. They're in the landscape. They co-occur with my restoring wetlands, right? Where we're trying to establish Myrtaceae species. So I would say that the health of our economically and ecologically important species are intimately linked, and we don't understand those links well at this stage. There are many emerging threats. Some of them are wind-borne pathogens that are going to interact with different species in all of those ecosystems. And of course, locally, the density of the hosts is going to have a big impact on how abundant the pathogen becomes. But things like climate change, wind movement, other factors, climatic factors, and landscape use, the configuration of land use, is going to influence pathogen spread between ecosystems. So we want to try and understand those interactions better. Ultimately, we're going to look at how they interact to determine ecosystem health across the landscape. And to do that, we kind of have, well, I limited myself to 5 aims for this talk. So we're going to start by just mapping the location of myrtle species and the cumulative impacts on wetland forest health in the study region. So building on the models we have, let's get some fine spatial scale data of where Myrtaceae are. What's their density? Can we understand which locations are likely to host high pathogen loads? We're also, and this is kind of the cool stuff in terms of the models, interested in doing some stand-level modeling using some agent-based models to understand forest successional trajectories when they're affected by different emerging threats. And then coupling those models, the stand-level models and the forest-level models. Thanks, Robin. so forest stands, so patches of forest, whether they're restoring or native forests in the conservation estate on private land, doesn't matter. But linking up models of what's happening in those systems to the landscape level process. We've also had a really cool opportunity through Amanda to work to gather some oral histories, Ngāti Kahanunu and Ngāti Rangatani ki Wairarapa, histories of swamp mare values. So we're interested in mataranga around swamp forests particularly, and how these values play out in these landscapes. Because the synergy of those things should allow us to identify cultural and ecological trade-offs between myrtle-dominated systems and systems where myrtle species are not dominant. And finally, we would like to identify, and this is what I want to put in my final report for 3.5 years' time, identify some social and ecological levers to maintain and enhance the resilience of wetland forest. So I started by saying we're in a biodiversity crisis, right? And I think I would really like to see the work of this incredible group of people take some finite steps to reverse that. I don't want to parrot the National Science Challenge, but we really do need to not just study the decline. We've all spent our careers studying the decline, and I don't want to just stop on my watch from trying to come up with some real solutions, and that's what we're trying to work to in this project. Okay. There are a huge number of fabulous people to thank for this, and I won't read them all out, but these include our iwi collaborators, an enormous number of wonderful students, and just really smart people who like to run models. I love mathematicians, really cool people. Okay, There's also a huge number of stakeholders and supporters of this work already up to this point, and so we're coming into this with a culture of organizations ourselves. So thank you for welcoming us all. It's not just me; it's all this. So thanks for that. And yeah, kia ora to you for listening today. I'm happy to take questions in the panel.
Kia ora. Thank you, Julie. That's really awesome. And there has been a few of us have got questions over the last 2 days. What's happening in the new Bioprotection Aotearoa? So that's some of it. So I'd like to welcome you back to the panel, because we're going to have the question time, Dan and Lauren. And I've got this, so. They've been wonderful speakers, so another clap, I think. I think you really do. So go. Now's your chance. I'm going to work off my desserts.
So one of the current concepts in kind of conservation and restoration is the idea of extinction debt, that no matter how much you've protected a landscape, it's programmed to decline. Species are going to disappear because the sizes of the sites that you protect are too small to maintain a population persistence. And particularly for Julie and the QE2 sites as well. Do you have an idea of, is that occurring? Are there sites that are so small that the efforts to protect them and conserve them in the long run won't actually deliver the outcomes? And so we should focus on larger elements of the landscape? Or is New Zealand different from many other parts of the world?
I would love to be able to answer that, and I'll try to in 3.5 years' time. So this is really exactly the reason why we're trying to understand the genetics of just one species in a fragmented landscape, right? The whole goal of Colin's work is to understand genetic structure, and we can do some fine-scale landscape work looking at seedlings, their genetics compared to their adult cohort above them, and to see how related the patterns of genetic variation are between those two demographic cohorts, to get at answers like extinction debt. I can tell you, if we don't know the genetic structure, we'll never be able to offset that extinction debt. I think as long as dispersal is occurring, and dispersal isn't just about connectivity of the trees themselves, but also their pollinators and seed dispersers. So there are many landscape factors that we need to consider, and that's kind of what I'm trying to do here, is get at some of those processes in the plant DNA. I don't know, did that? Yes, definitely there's an extinction debt, almost certainly, right? But we don't know what it is yet.
I got two answers. One is absolutely size is important, sorry. So we will have a minimum threshold of size that we would look at. Beyond a certain size, we'd just say, look, it's got no future. My second answer is to stop being so purist, So no, we can never recreate a perfect ecology of what was here pre-human, because half the species are gone already, right? And some of them might still be destined to be gone as well. But we've got to look after what we've got. You've got to start somewhere. Yeah.
Okay, Trevor Jackson again, AgResearch. I think a lot of the conversation, we're all aware that we're in this trend towards the extermination of species within the natural world and the decline that we're in. But when I'm in the fortunate position to be semi-retired now and have a bit more time to go around places, and I think that I've seen in my career, my lifetime, that we have turned a corner. At the moment, many of the bird species that we considered highly endangered, 20, 30 years ago, are now commonly seen within our protected areas. And we've done this because we recognise now the importance of those invasive predators within those areas and have got protection systems started for them. But as everybody said, this is in those areas that are under intensive predator control and under the DOC estate. But I'd like us to recognise that's been achieved. The challenge, as QE2 and Don have brought up, is how we go from that area to the rest of the landscape. And we do see with some of the predator control programs, changes around Christchurch, massive changes around Wellington, within those urban environments. But how do we actually get landscape design, those landscape corridors established, to how we link from the bottom, the QE2, back through the farmed landscape, back to the natural estate. And it's interesting, we're not the only people doing this. This is being done in a major way in Asia, with the oil palm industry, which I know a little bit about, being involved and taking responsibility for wildlife and preservation within the commercial environment. So, was there a question there? Anyway, perhaps it's a comment.
Yeah, I think there might have been a couple of questions in there. Just on one of your points, intensive predator control on the DOC estate, it's not really. It's mostly in either private estate or, sometimes local government controlled. That's certainly the Wellington situation, which I know about. In terms of landscape scale, connectivity, that's what we want. How do we get there? I don't know exactly. I think I can give you some examples of places where there is a locally driven vision. Taranaki Maunga is a lovely example where it's probably the regional council that's kind of stepped into a leadership role. They've gathered up a whole lot of important components of the community, including, the kind of greenies and the iwi people, and some private enterprise, and they've painted a picture of Maunga to see. They want to create corridors of connectivity between the peak of the mountain and the coast, because that's where the progression of food sources for birds, matures over the course of the season. So they've drawn a clear picture, they've provided some leadership, and people are getting on board, right? So QE2 does a huge amount of work in Taranaki, partly because the conditions are right and the community has been conditioned to understand this vision, and we're able to provide a little piece of the contribution towards that. So we will go and protect these parts of native habitat corridor that create those pathways from Maunga to sea. So I don't know if there's a policy prescription here. I think just going back to sort of Aroha's talk about, we think government's going to fix all of this. I don't know if that's the way we should be thinking. I think a lot of this stuff is going to be emergent. So throughout the agriculture sector, I hear more and more a conversation about mosaic landscapes, and agriculture is going to have to be a part of that, and production agriculture is a critical part of our economics and being able to eat. But can we make those landscapes a bit more sophisticated such that we've got space for the biodiversity in there as well?
I'm Stephen Goldson from AgResearch, part of a hard-bitten CRI community that's here, and we've noticed every picture's got a cow in it somewhere as the starting point of perdition. My only point is, and it's not a criticism, but a lot of the talks are talking about landscape restoration, and I'm not sure restoration to quite what, because it's difficult to get something completely back from what it was. There has to be a relationship with the farming community and the land users adjacent, and I don't think it's possible to ring fence certain ecosystems, and you were saying the same thing. I think it's a very important part of the conversation is mitigation and understanding between the cows and the ecosystems we so badly need to protect. Do you have any comment or thought about that?
I could talk your ear off about that. So I think that stocking rates are an issue that we have to address, right? Too many cows is too many cows. But I also know that the farmers that we work with are really pro-animal well-being, and a lot of these wetlands have been fenced for animal health reasons. They don't want to pull their cows out of a boggy paddock in winter. There are on-farm benefits to restoring ecosystem health. This is ecological infrastructure that's making their farm system more sustainable into the future. And I think we just have to change the wording around how we talk. We're on the same team, right? Like, these farmers are not in a battle with nature. They're just trying to make a living. And if we can make it safe for them to make a living in the service of food production for humanity, and still allow that to have a component of native biodiversity that is sufficiently dense and sufficiently connected that it can evolve to these emerging threats, then everybody wins, right?
Thank you, Stephen. I'm going to put it back on you, because I think I've been involved with agricultural research for a little while. Not pointing at any particular CRI, and I think as Julie said, there's a lot of farmers. Well, all the farmers that QE2 works with, want to do the right thing by the environment. I think politically and socially, there's been a sort of a massive backlash against sort of too many cows, and now farmers are feeling quite vilified and under pressure. And in a lot of cases, that's unjustified. In some cases, it certainly is. So if you've got a group of people, the first thing to do is stop putting them in a kind of a reactionary pushback situation where you're telling them they're evil, because that doesn't help to motivate. The second thing, I think, is start to talk to them about some of the benefits to their farming system that being a bit more at one with nature would create. So I've been looking for some time for some quantification of the benefits of shade and shelter to stock management. We're in Canterbury, sorry. Where are those numbers? So where's the evidence for farmers? Where's the evidence for farmers about the productivity impacts of feral ungulates on their parasitism? So what are the productivity impacts of some of those problematic environmental issues that are almost certainly impacting on agriculture as well? But nobody seems to be kind of quantifying and explaining and communicating the co-benefits to both the agricultural system and the environment of managing some of those problems. So there are plenty of people out there who want to do the right thing, and I think with a clear enough picture in lots of places, Stephen, about what that mosaic of a landscape looks like and what we're all working together to achieve, I think the farming community will get on board, no problem at all. We've just got to have the right social conditions.
So you put the question back to me. If you could repeat the question, please. No, it's fine. I agree with that. I think the sort of work you're doing and the results you're finding will be welcome by the farming community, the science itself. I don't think they should feel excluded from the science, and you're right about the vocabulary. The only other aspect that worries me, and it's not talked about very much, is increasing human population pressure on ecosystems. And I've been to so many meetings where we talk about environmental degradation and never talk about human carrying capacity.
That's politically touchy, Stephen, but I think it's wrong to say less humans. But just bear in mind, you need people to do conservation. So if conservation is a practice rather than a place, it's a practice that's undertaken by humans. So yeah, human pressure on kind of coastal lowland environments has kind of got us into trouble, but it's also the solution as well, right? If you want to control pests and weeds, given today's technology, and unless you guys are all going to fix that tomorrow, it's a very labour-intensive exercise. So having people around needs to be looked on as an asset rather than a cost.
Leo Condren here from Lincoln University. I'm going to put another spanner in the works here, and that is, are you familiar with the concept of carbon farming? Right. This is the idea that that there's a big move to plant 1 billion trees or whatever. But part of that is there's actually a company called Carbon Farming, which is planting up 90,000 hectares of pastoral land into radiata pine with the express intention of it being established into native. So are you familiar with this? And what are the challenges in this? There was an article just yesterday about the whole concept has been challenged by foresters in terms of have they actually thought through the process in terms of pests and weeds, particularly mammalian pests. But have you given any thought to that kind of, because, you know, in terms of carbon sequestration, we know that Pinus radiata's got its limitations, and there's a big preference in the Climate Change Commission to go to native. It's all very well talking about going to native. Doing it is very, very, very different. So is there any specific challenges in terms of bioprotection, particularly plant bioprotection, obviously, that you can think of in that kind of scenario where you're trying to move to more permanent carbon storage in plants? Maybe it's too much of a question, but I don't know.
Well, one of the issues there too is that soil carbon isn't even a part of any of those models at all. It's all about above ground carbon storage, which is one problem.
Don't go near soil carbon.
But also, yeah, and I mean it's a big question, right? And there are so many problems with. But I guess what did you say about the going from pine to native?
Pathogen load.
Plant into pine, but the intention is to transform to use it almost as a nursery.
Yeah.
For native.
Yeah.
With the idea of long-term carbon sequestration. And remember, this is about money. It's about dollars.
Mm-hmm.
Okay? It's not about ecological restoration. It's about carbon preservation.
Which is another issue altogether. I mean, you can monetize anything, and unfortunately.
Is there a bioprotection angle on the other side?
Yeah. Well, I mean, there's the obvious problem too with monoculture plantations, and you have those kinds of issues of what if a fire comes through, then forget about all your carbon sequestration. So it seems like going to any kind of moving towards diversity of anything is a better idea than that. But did you have another?
I think one of, this is not my stronghold area, but I do. Well, it doesn't matter. I think that one of the benefits of planting pine in the short term is you can plant it really cheaply, right? So it's bare root stock. They plant it by the hundreds of thousands. The production mechanisms are all sorted. If you plant restoration plantings, come with soil on the roots. We don't have those methodologies worked out for the nursery production of stock. So that's a major cost savings. It's 9 or 10 times more expensive to plant natives than it is pine right now. And pine, for as much as we all love to hate pine, the one thing it does do is suppress weeds, right? If you get a canopy cover, you can suppress the pasture grasses, which at least in wetland restorations are your major competitor, right? Our major suppressor of restoration outcomes is getting canopy closure, because tall fescue is so competitive with your restoration plantings, right? So if you can suppress that with pine on large scale, plant it cheaply, and slowly introduce an understory of native species, I think there's some economics there that are worth considering. How that affects things like pathogen load and transfer from pine to native species, I can't speak to that. I was hoping that somebody here could. Does anyone? My question back to the audience.
No idea. I think one of your colleagues, Professor Norton, came out with some comments about the stated ambition of transition of radiata plantation into native, and I think it's fair to say there's a fair bit of scepticism about that, how that's going to work, and we've got all the fire and pathogen risks. As far as I'm concerned, that New Zealand's missing a massive opportunity to create permanent, proper native forest through its ETS settings, basically. So it's nigh on impossible to register forest, native forest, either planted or regenerating in the ETS, and so we're unable to capture that benefit, whereas planting a plantation of radiata, they can. So economically, I understand exactly what they're doing, but I think the idea about that reverting to native is more optimism than science. I would just take one issue at this point with one of Lauren's slides, because from a conservation perspective, we love gorse, right? And you guys have got some wonderful examples on the Banks Peninsula of if you've got a good paddock full of gorse, just leave it alone, and that provides a great leguminous nursery crop. So, sorry, that didn't really answer the question. But.
Hi, JJ, I'm in Plant Food Research. I was interested on your opinions about the people aspect of this. So there's this mass, at least it's portrayed in the media, this mass exodus of people from the rural communities into cities and sort of the centralization of human capital, as we like to call it, in cities. Is that part of the problem, or is that an opportunity that we can dip into? And how are we addressing it in like looking at fixing or restoring the rural communities, the rural landscapes that we've destroyed so far?
Could a social scientist come down here and take this question?
So I don't have the answer to your question, Jay, but my personal philosophy is that conservation is a sociological challenge by and large, and that actually we're looking for humans to contribute to it. There's no coincidence that it's around the cities that you are seeing massive kind of restoration, pest and weed management activities starting to spring out of communities, because that's where the people are, and there's a sufficient concentration of people who are motivated to do this stuff. In terms of urbanisation and loss of rural communities, I'll just link back to that carbon farming conversation earlier. That's a surefire way to get rid of people out of the rural areas. So I think there's going to be quite different challenges, and for you guys dealing with pests and weeds, conservation pests and weeds, where there are no people, there's going to have to be a much smarter technological solution because I'm in, as I said, in Miramar. We're trying to kill the last rat. There's about there's hundreds of volunteer community members like me, and there's about 70 now paid full-time employees, and chasing that last rat through labour effort alone is really tricky across 2,000 hectares. So try and do it across New Zealand, and it ain't going to be possible, using those techniques.
And there's also the issue with the buy-in, right, of just getting people to be really interested in having people do that work. Those are more people who are getting involved and more people thinking about these kinds of things, because it's really a change in attitude too, isn't it? That's important.
John Rodwell, just an element which I'd like to introduce, which Dan, you provoked my thinking around. And I think, being a dairy farmer, as I am, in this room, I would put it to you to ask your responsibility as consumers around judgments around the food and the fibres you choose to buy, and the sacrifice or price premium you might pay to support those farmers who want to lead the process of land restoration and stock reduction and all the things which can be talked about very eloquently, whether or not as a society and as people and as individuals to play your part to actually get behind and encourage and support best practice, and in some ways share the cost and the burden associated with doing that.
Thanks, John. I think that we've noted a couple missed opportunities in this discussion, one around the ETS. Another one is celebrating those 37 farmers who are doing this out of their own blood, sweat, and tears, and free time, hard work. And there are lots of like-minded farmers out there. I hope that I said that in my talk. I certainly tried to. I think a missed opportunity is marketing those people. If the people in the cities see dairy farmers as the enemy, we've all lost, right? But if people in the cities see high value added nature-based farming options, organic milk, I don't know, like pollinator-friendly milk on their shelves, there will be people who will pay that premium. I think that's true. It's a personal opinion. I'm not an economist. Yeah.
Part of my many roles and my interest here is that I am involved in an initiative called Aotearoa Tangata Ora, which is creating programs and pathways for farmers to embrace all the elements of te tao and be seen to embrace them, not for their own personal satisfaction only, but to be able to provide the kind of signals and an authenticity to consumers. And this is not intended to be a pitch for that, but it's simply to pick up on your response, which is, yes, these things are important, and if they can be captured as structured, authentic, measurable advances, then there is an opportunity to represent that within communities and within the marketplace in ways that might accelerate the rate of progress towards this best practice.
So, John, my answer is kind of yes, but so yeah, I mean, lots of members of the agricultural community are trying to find a way to reflect the environmental practices of their suppliers through to the consumer. You and I both know that's really hard to get that message across clearly, and then when you do get the message across clearly, consumers' stated ambitions about what they want out of the world don't always translate into their purchase decisions. But now the but is stop being such an economic rationalist. Stop seeing the world through that view that behaviours are only driven through economically rational decisions, right? Because they ain't. So Kiwi2 farmers who protect stuff don't do it because there's any economic incentive for them to do it. We subsidise their costs, right? So to put a fence around their wetland costs them money. We'll help subsidise that cost, but it costs them money. They don't make anything out of it. They can't register in the ETS. There's no money in it. They do it often because they love it. And it's because it's important to them. And then when they do get out in their piece of bush or their wetland and do their trapping and weeding, they really enjoy it and they feel happier as people for having done it. So yes, economic rationalism I think is important, but it only goes so far and it's not the sole reason that people do things, you know.
Julie asked if maybe a social scientist could comment a while back, and my name is Anne Brower, and I teach at the University of Canterbury. And I think I'm a little bit on the side of John. Actually, no, I think I'm quite strongly on the side of John. You know, it's not about, sorry, Julie, it's not about reframing and, you know, rewording things because we're actually closer than we think. It's not about attitudes, Lauren, sorry. It's not about values. A lot of it comes down to the brass tacks of the economics of it. And if we can fix the economics of the situation to produce the outcomes that we want, then we're going to start getting outcomes that we want. Attitudes and values drive about 17% of human behavior. So you can preach to farmers all you want about, or all we want, about how they should change their attitudes and their values about their land. Their attitudes and their values drive about 17% of what they do on the land. So if we want to change the outcomes that we see on land, we've got to change bigger things at the regional, possibly district, and certainly national levels that change the economic and institutional and rule-based situation in such a way that will produce the outcomes that we want. If we don't do that, preaching to people to change their attitudes or values ain't going to get us there.
Thanks, Anne. I don't disagree around economic incentives and drivers, but I do disagree that well, no, maybe attitudes, sorry, I'm not a social scientist, but let me just give an anecdote. Often when we do some QE2 work in an area with one sort of pioneer person, you often see a sprouting of a whole series of QE2 covenants will pop up amongst the neighbours of that person. And it's not because of the attitudes and values of the neighbours changing, it's because the first person says, actually that was a really positive experience and I enjoyed it, and now when I'm out there I really enjoy being out there. So it's about personal gratification rather than any values. And they tell their neighbours that was a positive experience, and once they hear that from a trusted person, they give it a go, and often they enjoy it too, and so you get a kind of a snowballing, a chain reaction. I don't know how that stacks up in social science, sorry.
I'm going to add something. Ngā mihi Stacey, I remember your kōrero with me about your favourite program on TV was Country Calendar. And ngā mihi because it's always about seeing yourself by your own community, and we in the focus orchards, or seeing those exemplar growers, farmers, and how they are doing new and innovative practice is often a way. But I'm not a social science, I just like TV.
My name's Darryl Heron, I'm from Scion. Just thinking about all this going on and trying to unlock resources from human capital to money. I think we all understand the benefits of returning native systems, restoring ecosystems. We see that and everybody knows that. And trying to give people incentives to do this, I'm thinking about some techniques and tools that other people have used. So like citizen science, if you're turning farmers, people in urban areas into citizen scientists to get involved in the science process and designing experiments, taking measurements for you. Thinking about like crowdfunding. I was thinking about that thing that they do in Scotland, where you can be a lady or a lord by buying pieces of land, but you can be anywhere in the world, and you get a little title, and that's your land, and it helps with conservation. So if you've got people moving in urban areas, people moving up in social classes, making more money, maybe they can put that money into buying land in rural areas to help restore it. That way they've got an invested interest there. They can become citizen scientists by helping with experiments. They learn about what it is you're doing, why you're doing it, why it's important. And so you get a buy-in that way, just by involving people more and using all that resource. If someone's contributing $100 every now and again, that's a lot of money you get from a few million people.
Kia ora.
Thank you, and I think just in general from what you said, Anne said, and everything, and from the talks yesterday and today, what it really takes is everybody. It takes policy, it takes media, it takes scientists, right? And that's kind of why we're here, is to bring all of those minds together to make all this happen, I think, right?
Don't forget the farmers.
And the farmers, especially.
Yeah, so I'd just echo Lauren's point. So don't think about how money's going to solve the problem. So if you double DOC's budget, maybe they'll have 4,000 people and each one will only have 2,000 hectares to look after each, right? It's never enough. You need people on board and kind of all New Zealanders on board. I've talked about private landowners because they're in a sort of a unique position of being the guardians of a little piece of land, but really you need all of the New Zealanders to be on board and doing stuff. It's not a buy, a fix to the problem.
And I guess I've just been mulling over Anne's statement because I'm sure I don't want to argue with a social scientist about social science issues, but I am sure that it's true that 17% of human behavior is motivated by our values. But I also know stats that say you only need 25% of a population to be thinking any one thing to make massive social change, right? So we don't need those other 83% of farmers to use best practice. What we need is the people who will get on the tractors and spray the weeds and fence their property. If we target the ones that are willing and are able to contribute, we can make massive gains. And these gains are not going to come by shuttling more money to dock and the private estate. This has to be on private land because that's where the most endangered ecosystems are.
Well, kia ora. Oh.
Nick run up the back, really. He's been doing a great job. But I just wanted to point out in terms of how important the regions are. Many of us live in the cities. And so yesterday, if you think about the kōrero that was given to us yesterday in and around Kaitiaki, Māori stay in the regions. They don't move. And so it makes sense to work in partnership with Māori because they will remain as kaitiaki. And so, just catching my breath from running up the stairs. When we talk about kaitiakitanga, essentially it's the practice by people to sustain those lands. And so it's either obvious or not obvious to people. Many Māori, regardless, will continue to uphold those practices. So provincial growth is essentially, for me, about creating jobs in the regions. So if we can create mahi in the regions around us, people will stay or come back to either where they're from. And so I just wanted to point out just that kōrero in terms of toitu te whenua, toitu te tangata. Regardless of what goes on, the land will remain. And so yesterday there was a kōrero, Nick, in and around how we treat the land is really important. For me, if you can create jobs, and it comes back to a little bit of what John was talking about, if you can continue to create jobs or a reason for being in those regions, then people power, the communities will come together to enable, I think, those areas to thrive. But this is why Māori will stand so strongly, coming back to Aroha's points as well, because I guess the practice of those cultural elements are significant. But yeah, I actually didn't want this, really. I just wanted to make Nick run, but I think it's really significant to point out the role of Māori and tangata whenua in this. So I just wanted to bring here to you.
Kia ora. Kia ora, Stacey. And with those wise words, we're going to wrap it up so you can have some kai. And I'm keeping it here so they can. So I would like to thank all our speakers, Dan, Julie, Laura, and of course the wonderful Aroha from afar. And enjoy your lunch. Ka kite.
we're all good over here. 1, 2, 3, Merry Christmas. And the microphone shall sing. It's quite noisy and quite helpful to make noise into. Looks like it's got a standard setting there. Microphone, there we go, look at that, a bit of level.
Yeah, but
level.
it's not ideal.
Is it too high?
No, it's not that. It's the webcam rather than the USB internal.
Oh, okay. We better tape over the microphone, you think?
No, it's not that. Talk again.
Merry Christmas, and the elephant in the room has just left. He's hungry. But that's right. Yeah, we had it night before. It was just leftovers, so she doesn't eat any cheese or anything like that. She can eat that. Flexitarian. No, it's just purely because of the whole cancer. She just wants to knock it on the head. Yeah. See if it makes a difference. Fair enough. Fair enough. But says it's fucking hard. Yeah, everything becomes quite bland. Right. Until you get, apparently until you get all the sugar out of your system and you start tasting the real flavours. Wow. So she's got all the sugar out of the system. Pretty much. Wow, that's awesome. She's losing weight like kilo a week. Like, without trying. Wow. Yeah. Oh, well, it's an addiction. Absolutely. Absolutely, yeah. We watched a documentary called That Sugar Film. Australian guy who ate really well too. His wife was vegan. And he did the whole sugar thing. And he said, it's just bizarre. He said, what it does to you. And it took him, he binged for, I don't know, about 4 weeks. He went off completely off sugar. Just, cold turkey. He just went killed him. It was horrible. He stayed off for about 2 months or something like that. And when he went back to normal, even to his level, he said it was hard work. Because he's not a sugar fan or everything, but he eats pretty carefully. Yeah. He says even detoxing back to his normal levels. That's like the fire.
So he just didn't like it when he went back to sugar?
He just found it really hard
To get off it?
And then to go back to normal. He said it was kind of like a detox again because he did this binge on sugar. It took him about a month to get off it. He says it was like detoxing from bloody drug addiction.
Yeah, it's scary, isn't it?
privileged as I am to be standing at this auspicious time speaking to you about absolute drivel, nothing at all. Because going through my head is fresh air, and fresh air is the best thing since sliced bread. Sliced bread, on the other hand, is full of gluten if you take the wrong sort. It's a weird level. I can't see any microphone level going through that speak and pause. Did you hear a replay? No, I didn't. No input level from the USB mic, so all under control there, Jaron. I see it's. Oh, you've muted the mic, have you? Can't see your level rising either.
No, that's not there.
Huh. Microphone USB audio codec. Great cup of tea, John. I love that. Microphone HD webcam. Speaking the microphone again. Microphone USB to try another. Oh, there we go. Something just changed there. All microphones are being tested. No, try the other. No, well, there's something there. What's happening there? HD webcam 6.1. No, it's not that one.
Yeah, no. The desk isn't working for some reason, but this one.
Ah, so just back to what you had before.
Yep.
It's nothing to do with like cable power or anything. Yep, 130. Stu Hutchings.
Hi, Stu. You should be able to hear me. Yep, I can see you nicely. Thank you very much.
Can you hear me?
I can indeed.
Good.
So basically, yeah, there's not many people in the room. We're back at 1:30. So what we'll probably do is, after you're introduced, so you can just be in the background. You won't be seen until after you've been introduced, and then I'll bring up your screen. Either you can have your PowerPoint ready and to go straight into it, or you can have, we can actually see your face, and then you can share your screen with your whichever way you'd prefer to do it, whichever you're more comfortable with.
Okay, what I might do now then is I'll just jump in, share my PowerPoint now, and just make sure that works.
Yep,
be the
sure.
thing to do. Oops. So.
And will you hang around for the question and answer session, or because the way that they've got this scheduled is there's a couple of speakers after you, and then they have a panel discussion?
No, I'd rather do my question and answer straight after my talk.
Okay, great.
Yep.
In
if I
which
can,
case, then, can you please just at the end of your presentation unshare your screen so we can actually see your face at that point?
Okay, no, I can do that. So can you see my screen now?
Yes, we can. Thanks. If you'd like to click
Okay.
click through a few slides.
That working?
Yep, that looks great. Thank you.
Okay.
So
I'm, well, what, seeing as I've got it up, I might just leave that because on mine I can now see
Sure.
myself and the audience, so that works. So
okay, that's fine. Good as gold.
okay, I'll just mute myself in the meantime.
Thank you. Okay.
So just so I'm clear, at the moment you can only see my screen and not see me and the screen, right?
Yes, that's correct.
Right. So yeah, is it preferable that I then start with me and then jump into it, or does it not matter?
Whichever you're most comfortable with.
Okay.
I mean, if you're fine with transitioning from you to the screen, then that would be great because it would just give us a bit more context. But with our last Zoom speaker, she was straight into the presentation and it was just very smooth.
Okay. Yeah, to save something going wrong, I might just leave it like this.
Yeah, good as gold. All right.
And then I'll stop sharing afterwards. Yeah,
Yep.
as you say, and then we can go to the questions at that point. Okay, sounds
Great.
like a plan.
And if you could just mute your audio and then bring it up when you hear your introduction.
Yep, I'll do that now.
Cheers. Thank you.
Okay, thank you all very much. Well, welcome back after lunch. I hope you're all refreshed and ready to go for the last session of this fascinating series of 2 days. Before we kick off with this afternoon's session, I've been asked to give the floor to Catherine Webb from the Department of Conservation, who has a brief announcement to make.
Thank you. We're live streaming already as well. Hi. Kia ora koutou. Ko Catherine Webb tuku ingoa from Te Papata Whai Doc. Just wanted to give a bit of a plug for our postgraduate scholarship scheme that is going to kick off again this year. Last year we started for the first time being able to support master's students, gave away 10 scholarships, and we've got one of those recipients sitting at the back, Alana Thurston. It's a really great opportunity to put your name in the hat. We're going to open this round in August, so we'll be earlier, and it's not going to be as pressured. So check our website, Google postgraduate scholarships. In August, everything will be up on the website, and you can apply and get a grant for some awesome work. That's all I wanted to say. Thank you.
Okay. Right, the normal programming has now been resumed. So I'm chairing this after the last session. My name's Philip Hume. I'm a professor here at Lincoln University, but also a project leader not only in the Bioprotection Research Centre, but also very happy to be a project leader in Bioprotection Aotearoa. This afternoon's session deals with the broad topic of biosecurity, and we've been very lucky to get our first speaker. Although they can't be here in person, they thankfully are able to Zoom in and give us a virtual presentation. But it's great to have somebody from MPI talking about biosecurity, because after all, they're the people who know biosecurity better than most. So I'd like to introduce our first speaker, Stu Hutchins, who is the Chief Biosecurity Officer of the Ministry of Primary Industries, a new post, and one which we'll be looking at with a great deal of interest in the future. Stu has a long history working within the broader aspects of biosecurity through his role in Osprey, and then subsequently in KVH, Kiwi Vine Health. So he's seen biosecurity issues regarding vertebrates and disease management. He's also seen the industry perspective, and now he's working within the Ministry of Primary Industries, giving him a multiple perspective of biosecurity. And I think that the presentation he'll give will be very insightful based on both his long career in the discipline, but also his future outlook. So I'd like to now hand the floor, or the screen at least, to Stu Hutchins from MPI to give the first address of this session.
Thanks, Phil. Tēnā koutou katoa, ko Tauhara te maunga, ko Taupo Nui Atia te moana, ko Stu Hutchins tauko ingoa, tēnā koutou, tēnā koutou, tēnā koutou katoa. Hi everyone. So many apologies for not being able to be physically present with you today. I guess this is biosecurity in action. I spent the last 2 or 3 days in Wellington, and but can assure everybody, well, I'm trying to assure everybody that I wasn't there over the weekend, and certainly haven't visited any of the places of interest that are speaking to you from there. I'd also like to send apologies from Penny Nelson. She and I were supposed to be co-presenting this paper in the initial iteration, but unfortunately she was unable to join with us today. So the topic that I've been asked to talk to you about is trends affecting biosecurity, and then some of the things that we can potentially try and do about that. So if we think about what are the key risks that we worry about with biosecurity, I guess one of the major ones that jumps up and hits us is those risks that would immediately stop or restrict our ability to export products. And there is an internationally agreed list of animal pests and diseases that fit into this category, and the obvious one that jumps to mind for everybody is foot and mouth disease, as this would immediately trigger a whole host of other countries to restrict our meat and dairy and animal exports. And potentially the data suggests that if we got foot and mouth disease, estimated that we could have $15 to $22 billion worth of impact on our GDP over the next 10 years or so. So pretty significant. There's a number of other pests and organisms that sit in this list, and one that I've certainly had personal experience with is fruit fly. When we had the response a couple of years ago in Auckland, and having been involved in the kiwi fruit industry, pests like that create a whole lot of nervousness from a market access perspective. So then we've got those organisms that can threaten our taonga species or natural ecosystems. And the obvious one that everybody's aware about there is kauri dieback and myrtle rust. And these are a concern because of the impact on our iconic species and in fact the whole of our ecosystems. But there's a vast number of insects and fungi and bacteria and plant viruses that threaten our native biodiversity. So we need to always be thinking about this, because often what happens is people focus their interest around those that are going to impact our primary sector productivity without thinking about what could actually happen in the native estate. Unfortunately, there's very little scientific information about most of these risks, because most of the organisms that are potential threats there are not pests in their home environment. So it's very difficult to work out what would actually happen should they come here. So if we think about those pests that could harm our primary sector productivity, an example there is something like Mycoplasma bovis, but also brown marmorated stink bug, which is a hitchhiker pest, as I'm sure you're all aware of, threatens over 300 species of plants, and is something that we've been a huge amount of effort to try and prevent by focusing our efforts offshore, so that we don't have to deal with this either at the border or post-border. It's been really successful, so focus on identifying those countries that have high levels of risk, and then working very diligently to try and manage that risk before it leaves that country of origin. So with that one, the cost to the economy is estimated at being potentially about 3.6 billion over 20 years, so of major concern there. Then if we think about those that affect our human health and well-being, so the zoonotic diseases. So our biosecurity system focuses on the zoonotic component, but if it becomes a human-to-human spread, like COVID, then that's something where the accountability shifts across to the Ministry of Health. The final thing that I guess that keeps us up at night is those that are already here in New Zealand and are causing harm. And the ones that I've certainly had a focus on in my previous life with Osprey were possums, because of their activity as a vector for spreading bovine TB, but also stoats, weasels, rats, just to name a few of those. And thinking about endemic diseases that are here like salmonella, we're currently dealing in a response there, as you would have heard in the media, with relationship with the poultry industry. There's a whole host of weeds and aquatic pests that are also of significance there. So New Zealand doesn't have a top 5 per se that we focus on with this, as many overseas countries do actually try and enumerate the top number. We more think about what is the likelihood of something actually being able to get into the country and establishing, and then what the potential impact that would be. So that's how we focus our key risk activity going forward. But our risks are changing, and the whole environment in the world is changing, and this is something that we're finding that we have to be really adaptive about. And e-commerce is certainly a pathway that's constantly changing and growing there. So it's something with biosecurity that often in Biosecurity New Zealand we debate quite often is the fact that trade is a key driver for New Zealand, but often when we're focusing entirely around biosecurity, we're focused on risk management, and there are those that would like to have zero risk, and certainly when you talk to members of the public, they just say, well, why don't you just stop everything at the border? Whereas, of course, we have to be able to facilitate New Zealand's ability to have our economy survive. And if we look at the primary sector, you know, it's been looked to help us recover post-COVID. And so the horticultural industry, especially with our strategy around Fit for a Better World, has been looking to facilitate our growth there. With travel, I mean, if you think, and you're all aware that pre-COVID, travel was just starting to become such a fundamental component of everybody's daily life, you know, people traveling internationally, more products and equipment and anything really was able to, the ability to move it from A to B just didn't seem to be an impediment. And I certainly feel that that climate has changed significantly with COVID. At the KPMG agribusiness agenda that was released last week, there was a really interesting point made in there, which was, of course, in New Zealand, we take this for granted, our ability to move around our country and do business, albeit somewhat restricted. But what we've got to think about in the international perspective is that a whole lot of other countries don't have that luxury. So we've got to be very careful about assuming that our paradigm is the same as what others have internationally. So the importance of communication and understanding of our markets and risks is a key one. The environmental factors are pretty huge, and there's a number of those, and I won't go through them all, but changing temperatures with climate change is an obvious one there. As we get increasing temperatures with global warming, then the risks for biosecurity change, especially around the concept of changing land use as it becomes more accessible for some types of land use to become a bigger driver than others. And what we are seeing is change towards more horticultural inputs in some areas and changing away from farming or dairy type. So water use is a really significant one there, not only quantity of water use and drought and restrictions around that, but also the quality of water and impacts of what we do with that water. So it's something that can certainly have a huge impact on biosecurity. Water or lack of water can lead to stresses to plants and animals, and that can lead to increases in susceptibility. Other environmental factors that we often don't think about is we've got a changing political landscape. So we've got drivers, very strong drivers at the moment for changes in social structure and infrastructure development, and all of those can have flow-on impacts into the risks that we face. And the final one, I guess, to think about is the regulatory environment. So we've currently got the Biosecurity Act under review, and that's a massive opportunity for us to be able to change the perspective of the way we think about how we manage biosecurity in New Zealand and shape the future for how that gets managed and how we do deal with those risks. But there's other regulatory environment changes that we deal with as well. So the change in agrochemical use, the change in social license around those, and certainly that can have an impact when we're thinking about treatments or post-border aspects of biosecurity and the whole concept of the consumer-driven approach to the use of agrochemicals. The biggest one, I guess, we've got to think about is COVID-19 and the change in risks that that's created for biosecurity. The obvious ones there is everybody says, well, it must be okay because our air passenger numbers and cruise ship numbers have just plummeted. So estimates of up until the bubble opened, down by 95% and no cruise ships coming in at all. However, we've got to also think that with the bubble increase, we've got things that happen like Wellington, as I've talked about yesterday, where suddenly we are being thrust into a situation where the environment changes around that. So with the changes in those passenger travel, there's also quite a lot of changing that we need to do in thinking about how we manage this at the border. So there's changes in patterns and behaviours associated with different styles of travel or different countries coming. So we have to recalibrate how we target our risk assessment at the border and all of the pathways. It's been very interesting with the increase in e-commerce, which has gone up about 20%, and that tends to have replaced some of the mail pathway. So that's down by 30% because what's happening is a lot of the e-commerce is driving the mail system into the cargo pathway rather than into the mail pathway. So that means we've got to change our focus and where we put our efforts in terms of border staff. So if we think about some of the lessons that we have learned out of COVID, but also the responses that we've been dealing with, like Mycoplasma bovis, I guess the biggest one that constantly we think about and get reminded is that we are in the biggest biosecurity response that we can possibly have. So that increases the public's general understanding about what biosecurity means. And a really good example about that is just things like quarantine, social distancing, basic hygiene, which have then had a massive impact on other aspects of public health, so decrease in influenza and transmission of other diseases. So the other aspect of that is the concept of thinking about layers of defence, and we can certainly use this messaging in biosecurity, is that it's not just a single aspect of the biosecurity system that reduces our risk factors like the one that everybody tends to point towards, which is the border, but it's actually a multiple set of layers across that system. So thinking about something like the brown marmorated stink bug, the real effort has to happen offshore, because if we can reduce the risks associated with that, then the numbers of potential interceptions that are going to happen at the border get reduced, and we've certainly seen that over the last year. And then, of course, the risks associated with post-border management of responses is decreased as well. So thinking about the concepts as layers of defence is one that is really sensible. So also a big part of this is understanding the implications of our decisions. So so often when it is only focused on a particular part of the biosecurity system, then the resultant decision that occurs is only focused on that part, rather than trying to ensure that our decision makers are thinking from a system perspective, so that all of the time, how will this impact on the wider system for biosecurity? And the real key lesson that we've learned, especially out of Mycoplasma bovis, is that it's really important that we have simple, honest, clear and timely communication to the public and the decision makers. And I think this also flows over to the messaging that we have out of science. When I was with kiwi fruit vine health, and we did a lot of research every year into PSA, but also other biosecurity risks, a real focus that we always tried to have is when the research finished, what does this mean? What's the message that we're going to take out of this work? How are we actually going to change behaviours as a result of this piece of work, so that we're not just focusing on science for science sake, but what it means in terms of changing those behaviours as a consequence of that. So if we think about the system approach, I've used this diagram before, and although I don't particularly like it in terms of how it does describe the system, it is good with that concept of offshore having a large amount of risk, and then rather than us thinking about the system as being a wall that stops things, that it's a series of nets where each time you activate a part of that system, you're acting to catch a degree of that risk. And so by the time we do get through into the post-border space, and we're using surveillance and incursion investigation, building readiness plans, or having to do responses or move into long-term recovery or pest management, the risk associated has been hugely reduced by having that system approach. So we have some key outcomes that we try and drive in Biosecurity New Zealand, and the first one of those is that our biosecurity system is stronger, including our own business processes. So this is having excellence within the work that we do as an organisation, that our imports and exports are key to our markets and that they contribute to New Zealand's growth and prosperity. So this picks up that point I had at the beginning of my talk, that the impact of harmful pests and diseases in New Zealand is able to be reduced by how we use our biosecurity system. And then the final one, which I'm sure a lot of you are familiar with, the kōtātau process, you know, that we're involving 5 million New Zealanders in thinking about biosecurity. And how do we actually create that behaviour change where everybody doesn't think that it's the government's problem or it's the problem at the border, but that everybody can have a part to play in managing their own biosecurity risk. And the creation of concepts like on-farm biosecurity risk management plans and on-orchard biosecurity risk management plans are a fundamental part of that. So everybody thinking about their own farm or their own orchard as a biosecurity unit, and that they can actually try and reduce the risk by having some key processes in there. And that's where we draw on those lessons out of things like COVID, so that you can have that system approach and think about things like basic hygiene can have a direct impact in reducing the risk or reducing disease should it come along. So what are the opportunities that we can think about moving forward that comes out of all of this? So obviously and major one there is using COVID-19 and the lessons that we've had out of that to increase our biosecurity literacy in New Zealand. There's a whole lot in the technology space, and I'm guessing that as part of this conference, there's been a lot of discussion about where technology can help drive through science effort to improve our ability to manage biosecurity risk. So in budget 2021, there was $8.9 million invested to try and develop advanced screening technology at the border, so purchasing 3D scanners and developing data screening system to identify potential risk goods before they arrive here. So in the first scanner for that's been installed at Auckland's International Mail Centre by the end of this year, once that mail centre's up and running. Or concepts like the Bug, or what's called the Bug, which is a new inspection robot for clearing imported vehicles. So it looks like a bit of an all-terrain skateboard, but it can easily get under cars, and it comes with a couple of cameras, and one of them which has thermal imaging device, so can help detect insects. A key one, obviously, is the fundamental ability to share data and have technology that's able to utilize data in a way that can allow good analytics and risk management to occur. And for me, this is a major gap. It's something that we've talked about for a long period of time, and yet we don't seem to be able to bridge that gap and start the process of how can we fundamentally store, utilize, share, and analyze the data that we have. We think about pathway approaches as an opportunity. So often our biosecurity effort is focused at the single organism or the single pest, rather than thinking about what are the pathways by which we can manage the risk. And one of the experiences I have had when I was at Kiwifruit Vine Health is the beginning of creation of a pathway management plan, which is one of the instruments under the Biosecurity Act. And the concept there is again, in that post-border space, having our orchardists being able to consider what are the risks for biosecurity coming onto their orchard and how do they manage those. So risks like soil, risks like plant material moving around, risks like contractors coming onto the property. So risks like the types of composting that they're using. And so how to actually assess those risks and try and fundamentally manage or reduce them at the orchard level, so that should we get an incursion, they're at that next stage of preparedness and are thinking about this as part of their daily activity. Part of the concepts there is trying to embed biosecurity into people's mindset, much the same way as we've got health and safety embedded into the mindset through a major change behaviour process. So the collaboration within and across our system framework is a really key important one here. It's where we've got to ensure that we've got all of our stakeholders that are working in the biosecurity space thinking about how that they can work in a way that doesn't mean that we're getting parallel stuff going on within silos. And a big part of my role, the Chief Biosecurity Officer, is to start thinking and driving that thinking around a system approach to it. So I'm very conscious that we've got work going on in regional councils around regional pest management plans, work going on within DOC, work going on within industry, work going on within research frameworks, work going on within individual sectors. And yet often none of those actually start to join up or thinking about how that they can be aware of what's going on in each other's space, but better still collaborating or leveraging off that work. The final one there is around the legislative change, and that comes back to the opportunities that we might gain out of the Biosecurity Act review and trying to think about how we can take a more system approach to what we do there. So the final point I want to visit on is around the concept of Fit for a Better World. So this was a plan that was released by the government in 2020, and I'm sure many of you are aware of. And the aim there was to boost the primary sector export earnings by 44 billion over the next decade, while protecting the environment and trying to grow jobs. So, and this has been really a vital plan post-COVID, and has been looking to the horticultural sector especially to try and achieve some of this growth. And this is by accelerating access to and commercialisation of high-value plant varieties and products, and delivery of small-scale water storage solutions, which can then mitigate the drought risk, incentivising investment in land use changes to high-value horticultural crops. So it's also aimed around improving market access and aligning our research and innovation activities to help drive these change. Another key aspect of the Fit for a Better World is around the sustainability component. So supporting New Zealand's journey to low carbon emissions, low emissions economy by reducing biogenic methane to 24 to 47% below the 2017 levels by 2050 and include 10% below 2017 levels by 2030. And also thinking about restoring New Zealand's freshwater to a healthy state within a single generation. The final one there around the inclusiveness is the drive towards employing more Kiwis in the primary industry sector. So I'll finish up there because I'm conscious that I won't be able to join you for the question and answer session later on and open it up to the floor if you have any questions. I'll just stop sharing my screen now and you should be able to see me, hopefully.
Thank you, Stu. Questions?
My name is Jennifer. I'm a postdoc here at BPRC. We've been talking a lot over the sessions about the importance of collaboration across different groups. And one thing that I wondered is how you feel, how essential is international collaboration in protecting our borders compared to what we can do actually at the borders ourselves?
Yeah, I think if we recognise the concept that our best ability to reduce risk is offshore, then that collaboration internationally becomes incredibly important. It's also being able to take the lessons learned from those countries that already have the pests and diseases that we're trying to prevent coming here. And the example there I would use again is the kiwi fruit industry. So a lot of collaboration occurs in Italy and France with growers over there to understand the impacts and the way that some of these pests interact with the crops that we're trying to help protect. So being able to do collaborative research on the international space, I think can teach us a huge amount about how we can actually manage risk if it did get to come to New Zealand.
Hi Stu, it's Travis Blair here. I just have a question about the review of the Biosecurity Act. Where's that actually at?
Okay. Yes, so it has been quite a long journey, I have to say. And so where it has got to at the moment is that there has been a draft paper created for the Minister that includes a number of issues that have been identified through consultation quite widely with industry and other groups, and also some options that would be given for consideration when that goes out for consultation. So the aim is that consultation paper will come out probably a little bit later in the year, maybe around September, October. Don't quote me on the exact timing of that because that's coming from memory, but that's where we've got to at this stage.
So I might just take the opportunity to follow up on that. I mean, the other thing that many of us were involved with, Stu, this is Philip Hume from Lincoln University. We were all involved in the workshops for Biosecurity 2025. The various streams, Kotato, the team of 4.7 million, there's a technology one, a governance one, 5 different streams, which a lot of people, some of them here, put a lot of effort into. It seems that it's stalled somewhere. Is part of your role to resuscitate that Biosecurity 2025? Will we see that come to light in the next 4 years, or is it going to be refreshed and turn to something new?
Yeah, so yes, it is part of my role to look at that. One of the first jobs that I've got is looking across the whole biosecurity system and trying to map that system and then also think about where Biosecurity New Zealand sits within that. And one of the first places that I've gone to look, and I was also involved in the process of Bio 2025 and development of those themes, is going back and having a new look at what came out of that. Very aware that it has kind of gone into an abeyance type thing, and there was an incredible amount of good work that did come out of Bio 2025. So certainly I would like to see us revisit that. It won't be an iteration of the same thing, but it will certainly be picking out some of the key findings and aspects of that and taking that forward.
Great. There's a bit of a post-lunch lull.
Yes.
Well, I can ask lots of questions. So that might stimulate people to start putting their hands up because they think, oh, Phil, could you just shut up? You're talking next, so we'll hear enough of you as it is. The other thing I can remember a couple of years ago, MPI were looking at, again, developing much more of a science plan for biosecurity. I think under Ian Ferguson, there was a group brought together to look at kind of strategic science priorities. And I know an effort was made in 2007 and developed a science strategy for biosecurity. Is that still on the cards? Is MPI going to help design some kind of science priorities for biosecurity over the next 5 to 10 years?
Certainly, everything that we're trying to achieve as an organisation around our decision making and the way forward has got to be that it's evidence based. So having a science strategy and focusing the activity of that around having a system view of the biosecurity system, and then identifying where the key gaps are and what we can do to try and fill those is one of the drivers that I also have as part of my quite wide-ranging job description that is evolving as I move forward, because as we pointed out at the beginning, it is a new role, and so I have the luxury, I guess, of being able to shape it how I wish, but also being slightly scared about how big that can become.
Any further questions? Actually, for most of you, any questions at all? Because you're not really asking any. Okay.
The lunch must have been too good, I think, huh?
Yeah, well, Stu, I think we'd all wish you all the best in this new role. I think it's a really important role for New Zealand and for MPI. And your success will be eyed by industry, by science community, so no pressure at all. But I think it's a great opportunity to have really one person that's kind of a focus for the biosecurity system as opposed to the organisation. So all the best with that. And do keep the Bioprotection group here, Bioprotection Aotearoa, in your mind when you are seeking advice, because we are very happy to issue advice whenever we need to, but also see us as allies in terms of future work in the biosecurity space.
Absolutely. Thank you very much, and I hope the rest of the day goes well.
Okay, so after Stu, the next speaker is yours truly. I'll be giving a talk. I'm just waiting for my slides to come up. So I've introduced myself, so I'll just get on straight with the talk. I probably win the prize for the shortest talk title, but hopefully I can embellish that by some detail. So my talk is addressing a topic called One Biosecurity. And it may be unfamiliar to you because it's something that's relatively new. And I want to try and elaborate that as to why One Biosecurity might be an important step for how we not only protect New Zealand, but how we look around the world. So the following figure shows the trend since the early 1800s. In the black line is the number of alien species recorded somewhere in the world for the first time. And you can see that black line progresses upwards and onwards, relatively without too many interruptions apart from the Second World War, to the present day. And you can see it tracks very much global trade. And in particular, since the 1950s, the relationship between the number of alien species, alien plants, pests, insects, etc., recorded for the first time anywhere in the world, follows global trade patterns very closely. So what this tells us are two things. One is the problem of introduced species, whether they're pathogens, pests, insects, or mammals, is not new. It's been going on for at least a couple of centuries. The other thing is it's not going away. If anything, it's potentially getting worse. And so a lot of these organisms cause major economic, human health, and environmental problems. And so we need systems in place that can actually mitigate and prevent the impacts of these organisms. And the basic issue here is that the basic approach is to apply biosecurity. Now, what is biosecurity? Some people feel confuse it with the term Bioteroa, but it's defined not only in New Zealand but also by the United Nations as a strategic and integrated approach that encompasses the policy and regulatory frameworks for analysing and managing relevant risks to human, animal, plant life and health, and associated risks to the environment. So, and in New Zealand, it's the exclusion, eradication, or effective management of risks posed by pests and diseases to the economy, environment, and human health. So the key thing here, biosecurity, is not simply plant biosecurity, the topic that many of us have been working on over the last few years. It's a much broader theme and concept. And it actually is all-encompassing. It's a far broader, holistic vision of what biosecurity is than what is actually often applied either by scientists or by governments. And so it's this issue that it bridges human, animal, plant, and environmental health that forms the basis of this idea of one biosecurity, that there's one approach that we could adopt to deal with all these threats rather than dealing with them piecemeal. To give you an example, obviously we've all become much more aware of biosecurity issues under COVID. But historically and currently, many of the concepts within human health and the issues of dealing with a pathogen and issues dealing with a parasite or an invasive species have been dealt quite differently. But we can see that there's very many similarities between the two. If we look at a pathogen can often be moved around through a vector, and that process is described by a process of transmission. Similarly, an invasive species also has vectors. They just happen to be somewhat larger. And they, again, move species around the world, and our terminology for those is pathways. But if you get away from the terminology and the taxonomy, you can see emerging structures and features that mean that we could probably deal with the same conceptual issues, whether it's a human disease or it's a pest of forestry. But it's not only the process, it's the pattern. Here is the first SARS, when we thought we'd never hear about SARS again. But this is the original SARS in 2003, 2004, heading out from Hong Kong around the world in a matter of a few months. You can see this quite rapid spread across most of the continents of the world. Now, we often see this as a pandemic, and we tend to view pandemics as being driven by diseases. But if you look at many of the invasive alien species spreading around the world, their patterns are remarkably similar. So here's the red swamp crayfish. It was a species that's highly valued in aquaculture, but it can actually climb out of tanks and wander off and become established in rivers. And so as you can see here, while the timescale is somewhat different, the patterns of spread show similar kinds of trends, long jumps across continents, so that over a matter of 30 or 40 years, this species has become effectively pandemic. It's everywhere. It could possibly establish almost. And a more familiar organism perhaps is the bronze bug, a pest of eucalyptus, which again originated in Australia, more recent spread now and also quite fast. This has followed its host, eucalyptus species, again around the world, and is probably found in most areas of the world where eucalyptus is grown commercially. So again, these are global issues. They're not just happening in one country. There are pandemic organisms. And we can look at the rates of spread of these organisms, and true, pathogens do spread faster than other organisms. But actually, the differences aren't that marked. Apart from human health, the pathogens of human health seem to spread very quickly. But if we look at plant or animal pathogens compared to vertebrate plants or invertebrate pests, the rates of spread cover a similar order of magnitude. So while we might be concerned about COVID and the rapid spread around the world, many of the pest species that we're dealing with are progressively spreading wider and wider around the world. And as Jennifer mentioned, I didn't plant the question in her to Stuart, is that these issues are international. They can't be dealt with any one country by themselves. And certainly, no matter how the good efforts of biosecurity in New Zealand, you can't deal with this problem in isolation. The other issue is that when we compare with diseases, the whole issue of COVID has probably focused people's attention on the border and on biosecurity. And Stu said that in New Zealand, nowadays people are much more focused on biosecurity. But it's true for the world. If you look at Google Trends, if you've got a spare afternoon, what you can see is that the term biosecurity, as soon as COVID hit different parts of the world, people started searching for biosecurity. So that terminology now is in people's mindsets. And that means not only the average public, but also hopefully policymakers and decision makers. That what is biosecurity? COVID has brought that to our home. It's about the border. It's about pathways around the world. It's about surveillance. It's about detection and early response. All these terminologies that those of us who've worked in biosecurity before use as a general lexicon has now become almost common language to us all. But the problem is, we as scientists should be able to respond to this, but we're not doing a really great job. If we look at the science across the different sectors of human health, environmental health, plant health, and animal health, the circles here, and they're logarithmically scaled, so the research that goes on in human health is several orders of magnitude greater than either in environmental health or animal health. You can see that there's quite big disparities in the amount of research that's going on in dealing with these different topics. And the area that's closest to our hearts, plant health, gets relatively little attention compared to these other fields. But then when you look at the interfaces between those different fields and the kinds of papers that actually publish joint work, looking at the interaction, for example, between environmental and human health, you see other patterns emerging. In that there's much more joined up work going on between human health, environmental health, and animal health than there is with plant health. But even so, environmental health and animal health have relatively weak interactions. So the science system is disjointed. We tend to like sitting in our silos, and we don't necessarily look across to different disciplines to try and learn from their best practice. And part of this, and here's an Australian example, is the research we do is fundamentally siloed by our funding agencies. And here are some Australian CRCs. So there's the CRC in plant biosecurity, weed management, digital health, emerging diseases, invasive animals, tropical plant protection, etc. All these groups working on fundamentally similar processes, but working in isolation. And this is a fundamental problem because there are lessons to be learnt from all these disciplines that we're missing out on. This wouldn't be as bad, but it reflects actually the regulatory space that we work in as well. If we look at the international regulatory space, again, these are logarithmically scaled circles, the amount of money that goes to support the World Health Organization is vast compared to any of the other organizations. And we'd expect that, I suppose. Human health is a real priority. But if any of you can actually see the amount that goes to the International Plant Protection Organization, which is way down here at the bottom of the figure, you can see that the amount of resources going into international regulatory efforts within our broad area is tiny. And if you look at the amount of work that's going on in the interfaces of these areas, then you can see that much discussion has been occurring between the World Health Organization and the World Organization for Animal Health, but basically very little with the other groups. And particularly, the International Plant Protection Organization is somewhat left out on a limb. So we're not integrating very well in a regulatory framework. And why do we need this integration? Well, primarily because the future threats we're facing don't distinguish whether you're a human health pathogen or a plant pathogen or an animal pathogen. So we have greater urbanization. Urbanization are hotspots. Urban areas are hotspots for emerging diseases. They're entry points for pests. And the high urban natural interface means that organisms can spread from urban environments outwards. Climate change, we heard quite a bit of that from Anita yesterday. But again, an improved climate for pests, ecosystems become less resilient, and there are extreme events, all of which can accelerate problems of human, animal, plant diseases. And agricultural intensification means there's pathogen spillover to humans, there's facilitation of pest spread across landscapes, and the fragmentation of native ecosystems makes them more susceptible to invasion. So we do need a joined up approach because the pressures are common and we don't have the resources to work at them individually. Now some of you might say, hang on Phil, what about One Health? We've all heard of One Health. This is something that's being promoted quite widely. In fact, there's journals, a journal called One Health, there are books entitled One Health. And One Health, if you're not familiar with it, is designed to be a collaborative, multi-sectorial and transdisciplinary approach working at local, regional, national and global levels to achieve optimal health and well-being outcomes, recognizing the interconnections between people, animals, plants and their shared environment. So isn't that what we should be doing? Let's forget one biosecurity, let's just do One Health as a term out there. But when you scratch at the surface of One Health, you see some clear signals. First of all, it's dominated by the twin terrors of doctors and vets, who don't like each other anyway, but most of the science that's going in that space is dominated by human health, veterinary sciences, and disease biology. The actual environmental science component to that is tiny. In fact, it's only less than 7% of all the research going on in One Health addresses any interactions with the environment at all. And when you tease apart that element of environment, you can see that in terms of the environmental issues, it's things like zoonoses, antimicrobial resistance, and wildlife reservoirs. The issue of invasive species, biological invasions, and biosecurity just don't feature very strongly in One Health. And what I'd like to do is propose that perhaps this is the wrong way approach. Perhaps we do need something called One Biosecurity that can complement One Health, but can bring the researchers in a broad area of biosecurity together in a much more joined up approach. So let's begin with just a schematic to look at the interactions between the environmental health, animal health, and human health. And you can see the human health is the couple at the bottom there, and then the animal health is the cow, and then there's the environmental health, which is a wild pig with a tick on it, just to make sure that we cover as many taxonomic groups as possible. But you can see this transmission of, for example, of pathogens and parasites from wildlife reservoirs to livestock, zoonoses from livestock to humans, and of course, pathogens from wildlife reservoirs to humans. And this is the remit of One Health, really. But One Biosecurity is much broader because here we bring in plant health. And plant health links in very closely. So for example, invasive alien pests and plants reduce quality of food, which is a major issue for food security and human health. Mycotoxins from invasive plant pathogens in seeds cause problems to animal health. And wildlife reservoirs, as well as spreading diseases, can destroy crops and so have impacts that way. Weeds, my favorite topic, also fit in here as well. Pollen allergens are a major issue in New Zealand, and most of those arise from introduced plants. Invasive plants can cause poisoning in livestock. And invasive alien plants actually can actually act as hosts to some of the vectors that carry animal diseases. And of course, weeds can impact on plant health, and actually many crops can actually become feral and become weeds themselves, such as kiwi fruit. So as you can see, it's a much more holistic perspective of what biosecurity is, much more of a rounded approach that requires interdisciplinary work amongst all disciplines to deal with these kinds of problems. We can't view them in isolation. And a case in point, there are actually some pests that are cross-sectorial, like the red imported fire ant. Not only does that impact human health, it impacts livestock health, it reduces native biodiversity, and it damages crops. So again, a cross-disciplinary approach to these problems is required. So why do I think One Biosecurity is better than One Health? Well, partly because I'm kind of promoting One Biosecurity, and I'd like everyone to wear the T-shirt soon. But the other issue, I do actually find that One Health is a bit of a mask, and the more you dig into it, the more you realize it's not what it's set out to deal with. So One Health currently does not address issues that are major components of biosecurity. It doesn't really deal with the issue of international trade and human travel in how pests, weeds, and diseases move around. it doesn't actually understand or address the international protocols for sanitary inspections of imports and exports. One Health doesn't actually examine the effectiveness of biosecurity interventions, either at the international borders or at the farm gate. And it doesn't really use risk assessment tools to forecast or predict future threats. And it doesn't even examine the triggers of pandemic diseases outside of endemic areas. So what I'd like to promote is, while One Health might be a nice concept, it's not actually designed to be applied as such. It's very much a wishful thinking, at least in my eyes. And One Biosecurity broadens that concept to include strategies and policies for mitigating those risks, and more explicitly integrates the different disciplines of human, animal, plant, and environmental health. So just to conclude, what we're finding out through COVID is that biosecurity is essential in a world that's exposed to multiple threats of impact of human, animal, plant, and environmental health. Yet still, sector policies is sector specific, and that's a major flaw in terms of any international response to a major biosecurity threat. One Biosecurity potentially can bridge those sectors by bringing the different sectors together and provide greater foresight in the management of invasive species and diseases. Many invasive species tackle and impact multiple different sectors, and yet we often look at just one aspect of their impacts when we're trying to study those pests. And so we need to develop current risk assessment tools that can deal much more broadly with problems than just focused on our own little discipline. And the major future societal challenges, such as urbanization, climate change, agricultural intensification, will have impacts across all kinds of threats, independent of the sector that we're working in. And we're woefully underprepared to deal with those in our individual sectorial silos. So hopefully something like One Biosecurity, which brings the conversation together, and so that in the future, rather than have a meeting of mostly plant bioprotection individuals, would have animal health, plant health, environmental health, and human health together, will probably be the way forward. So with that, I'll finish. Thank you. Okay, so still me, but I have finished. The next speaker is Dr. Jennifer Bufford, who works at Lincoln University in the Bioprotection Research Center. Jennifer did a PhD in Hawaii, looking at invasive plants there and plant-animal interactions. And she must have done something really bad, because subsequently she's done a series of postdoctoral positions with me. And either it suggests that I'm a great boss to work with, or that for some reason all our other options have been closed to her. But I think hopefully it's the former. But anyway, I'd like to welcome Jennifer to talk about some of the work that we've done under BPRC, particularly looking at plant pathogens. So, Jennifer.
Thank you very much. Tēnā koutou katoa. As Phil said, I'm going to talk to you about some work that we've done together looking at bioprotection against fungal pathogens, and particularly we wanted to understand incursions and host range. So won't need to talk about this much because it's been well covered in the last two presentations, but we can think of border biosecurity as a continuum. It starts with what's going on actually outside of our borders, and other studies have shown that there are still plenty of pests and pathogens available to enter New Zealand. And so New Zealand and Australia are the darkest colored lines on this graph, but basically the point is that less than half of the pests and pathogens that could affect plants existing here in New Zealand are already present. So there's lots of pressure coming in from the border. And then, of course, there's what happens actually at the border when things arrive. And then what happens once an incursion occurs and things are inside our borders. How do they spread within the country, and how do they multiply, and what impacts do they have? So we're interested in looking at these last two phases, what happens at the border and what happens inside the border or post-border. And we thought that it's really important to look at these pathogen incursions, because it won't have to convince you that pathogen incursions can be really important. We've seen some really interesting work today of Kauri dieback, and we've heard a little bit about myrtle rust, and we'll hear more about that. Both of these examples show us that pathogen incursions can have serious impacts on our native biodiversity, on taonga species, and on our economic biodiversity and economic benefits that we derive from plants. So understanding pathogen incursions is really important. The problem is that pathogens are really small, and so they're quite cryptic, and it's hard to track them, it's hard to tell when they arrive, and it takes a lot of effort to actually find out what's going on. But the advantage that we have here in New Zealand is we actually have the opportunity to understand pathogens in a way that's not possible in a lot of other countries. So we're obviously very geographically isolated, and we've also been keeping really good records for the last 150 years or so. So in New Zealand, unlike most countries, we have a pretty good idea of what pathogens are native and what pathogens are alien. And we have much better records on what species are affected by different pathogens and when the pathogens were first found here. And all of that data has been collected and made available by Manaki Whenua. And so our collaborators, Jerry Cooper in particular, has been curating that database. And it is primarily focused on above-ground plant pathogens. And there's a heavy emphasis on commercial species because this is where most of the work historically has been done. And this is a database of symptomatic plants. So someone went out, they saw a plant with symptoms, and they determined what that pathogen was, and they've recorded the pathogen and the plant that it was associated with and when that was first observed. And so from that, we can tell when pathogens first arrived in New Zealand or were first detected, and we can also tell what plant species they associate with. And so this is the information that we've used then to look at what's actually happening at our borders. And the first thing we wanted to do is to look at how pathogens arrive over time. We wanted to know whether pathogen arrival is linked to trade or to tourism. So we looked at trade volume and air passenger arrivals. We also wanted to know whether pathogen arrival rates differ between different sectors of the economy, and whether we can see some evidence that our biosecurity efforts are making a difference. And so to do this, we looked at plants that belong in one of 4 sectors: crop plants, fruit crops, forestry species, and pasture species. And then we also looked at alien pathogens that were first recorded on one of those plants. And then we created a model that accounts for survey effort and the lag between arrival and detection to look at how many pathogen species were arriving on these plants each year across our database. So here's what we found. On the y-axis is the rate of pathogen arrival. So that's how many new pathogen species are showing up in New Zealand, are estimated to arrive in New Zealand in a given year. And then the x-axis on the far graph is import volume, so that's how much is coming into our borders. And then this one closest to me is air passenger arrivals, so this is looking at tourism. And what we can see is that between 1930 and 1980, we have a roughly linear relationship between trade and pathogen arrival rate. More trade, more pathogen arrivals. Each dot represents a particular year, and the red dots show you the decades just to give you a sense of the passage of time. What's interesting is we don't see a similar pattern with air passenger arrivals or tourism. So in that same set of time, from the 1920s to the 1980s, although pathogen arrival rate is changing a lot, air passenger arrival rate isn't changing very much. So we're not getting very many new people coming in, but we're getting a lot more pathogens. Trade actually provides a much better fit during that time period. What's interesting is that in more recent years, that's changed. So since 1990, we're seeing that pathogen arrival rates are relatively constant, but import volume continues to increase, as does air passenger arrivals. And we argue that this is evidence of biosecurity actually working, that as more and more biosecurity measures are implemented, we're able to increase our trade and increase our tourism without substantially increasing the risk that we're exposing ourselves to in terms of incoming pathogens. And so the 1990s, for example, is when stricter quarantine of live plant material was implemented. And it's also when some of the stricter regulations around incoming air passengers were implemented too. And we see that seems to be making a difference, and that we've decoupled trade from pathogen arrivals. Now, we wanted to see how this applied to the different economic sectors that we considered. So this looks at pathogen arrival rate across economic sector. And what you can see is that for crop and fruit trees, pathogen arrivals have been relatively steady over time. For pasture species, there was a big peak in the 1960s and 70s. And then for forestry species, we actually see that pathogen arrival rates are continuing to increase. But as we know from the previous slide, trade imports volume is important. So we wanted to account for that when we looked at pathogen arrival rates. So this shows pathogen arrivals per import volume. And what we can see is that for both crop and pasture species, there's a peak in the 70s, and then arrival rates decrease relative to the amount that's being imported in those sectors. By contrast, for horticultural species, it really hasn't changed much over time, and for forestry species, it continues to increase. Now again, we argue that there's a connection here with biosecurity measures. So in the late 1960s, New Zealand entered the OECD seed certification scheme, which provides for stricter regulation of seed imports. And that's going to be particularly important for crop and pasture species. But it didn't apply to a lot of fruit species. So we see that decline subsequently in crop and pasture, but it didn't have an effect in the fruit tree industry. For forestry, there was inspection of timber imports from about the 1950s, but that was mostly focused on invertebrates. And not only timber imports, but actually pathogens can come in on just wood packaging that's present in a lot of other commodities that are traded. Now, we do have standards around wood packaging, but that's come in quite recently in the 2000s. And our data only goes to 2014. So we think that we haven't seen the impacts of those kinds of biosecurity yet. So it's providing some compelling evidence that biosecurity implemented for crop and pasture species in the 60s, late 60s, early 70s, has decoupled trade and pathogen arrivals. But the lack of similar standards for forestry until recently means that forestry pathogen arrivals continue to increase throughout our data set. So the important things to take away is that incursions are continuing. We're still seeing the arrival of new pathogen species every year here in New Zealand. So this is still something that matters. But even though pathogen arrival is generally linked with trade, biosecurity has broken the link in some sectors. And that really emphasizes the importance of this biosecurity. Now, we also wanted to know what happens once pathogens arrive in New Zealand. What's the next step? Lauren talked about this a little bit this morning, but there's this idea of pathogen spillover. That is, we have both alien and native plants present in New Zealand, and each of them have pathogens, alien and native pathogens. But what can happen is that, for example, if an alien plant is present, hosts a lot of pathogens, those can then move over onto native species that are growing nearby. But we don't understand a lot about how this happens. So we do have some examples. Myrtle rust is a good example of a plant that is present on aliens, can build up into high abundance, for instance, in places where there's a lot of alien myrtaceae that have been planted, but then can spill over onto our native species. There are examples where that happens in reverse as well. So this is an armillaria that's a root rot of pine seedlings, and it's native. So it's native here in New Zealand, but when we plant out these pine seedlings, it can actually cause death, which if you're trying to grow a forestry plantation is a bad thing. If you're trying to control wilding pines, it might be a good thing. But we're interested in how often this happens, how common is it, and can we understand what drives pathogen spillover? And we were looking, again, at a national level using this plant pathogen database. So we had 4 key areas that we thought might influence the rate of these kind of novel associations between alien plants and native pathogens, or native plants and alien pathogens. And so we saw taxonomic similarity as something that's thought to be important. Plant defenses are often taxonomically or phylogenetically conserved, so pathogen will often infect multiple species within a genus. Contact opportunity is how much these plants, how likely these plants are to be planted close together or to occur close together, which should increase the opportunity for the pathogen to jump between them. Pathogen traits may also be important. In particular, we looked at whether pathogens could grow on dead plant material, necrotrophs, or if they relied on living plant material, biotrophs. And we also looked at residence time. How long have these species been present here in New Zealand? What we found is that we looked, the y-axis is the number of novel associations that are being formed, so associations between an alien and a native. And then the x-axis shows whether the focal species is alien or native. Now, the far side are pathogens, and then the side close to me are plants. So what we see is that for pathogens, Alien pathogens are slightly more likely to infect a native host than the other way around, although this difference wasn't very strong. But we see a stronger difference with plants. So native plants are far more likely to have an alien pathogen than an alien plant is to have a native pathogen. Now, part of that may just be a numbers game. 70% of the pathogens in this database are alien pathogens. So statistically, it's just more likely that you're going to get an alien pathogen on a native host. But the other thing that's really interesting here is that on average, every native plant had at least one alien pathogen. And actually what we find is about a third of the species in our database form novel associations, and that about 10% of all the associations in the database are between an alien and a native. So this isn't uncommon. This is actually happening a lot. And it's happening particularly to our native plants. The other thing we looked at, as I said, is we looked at whether taxonomic similarity was important. So this is for an alien pathogen. On the y-axis is the proportion of all its recorded hosts that are native. So the x-axis then looks at what are the alien hosts of an alien pathogen, and then tallies up how many species are present in New Zealand within those genera, and how many of those species are native and how many are alien. So if you infect a genus of plants that has a lot of native species, you're more likely to have native hosts. And that makes sense, but basically what it's showing us is that these alien pathogens are more likely to infect close relatives of their alien hosts. So that taxonomic link is important. We didn't find that the other traits we looked at were particularly important. So we found this taxonomic similarity really matters. If you share, if a native plant is in the same genus as an alien plant, it's more likely to share pathogens. But our measures of contact opportunity and pathogen traits and even residence time weren't that important. What was important is sampling effort. And this is important to mention. It's sort of obvious, the more you look, the more you find. But we do see in our database that sampling effort has decreased in recent decades, and often that's tied into availability of funding and resource priority. The problem is we don't know what we don't study, and if we're not looking, then we're not finding out what's going on. And it just really emphasizes the importance of actually continuing that monitoring post-border so that we know what plants are being affected, which pathogens are spreading, and what kind of impacts those might have. Now, the last thing we did is we actually put all of these into a network, and I'll just show you this very briefly. So the green circles are native plants. The squares represent pathogens. On the far side, those squares are alien pathogens, and on the near side, these squares represent native pathogens. The gray lines between a plant and a pathogen show an interaction, an association between them. The thicker the line, the more often that association has been recorded. The bigger the square or the circle, the more often that species shows up in our database. And basically what we see here is that we have a lot of native plant and native pathogen interactions, but there's a pretty significant number of alien pathogens that are affecting our native plants as well. And this is basically another way of looking at these questions. What we find is similar to what we saw when we looked at a species by species basis, that alien pathogens are more generalist. They connect across the network in ways that connect plants, and it's different from the way native pathogens do. And our concern here is that the way those connections are happening may actually increase the likelihood of outbreaks and destabilize this network of interactions. So, what we found is that pathogens continue to arrive, but biosecurity is making a difference in breaking the link between trade and pathogen arrivals. About 30% of all hosts and pathogens have some form of novel association, so this is pretty common. The likelihood that an association between an alien pathogen and a native plant will form does depend on how closely related that native plant is to alien plants already here. But alien pathogens are more generalized than native pathogens, and that changes the network structure in ways that may destabilize the network and make it more prone to outbreaks. So, why does this matter? It shows us that biosecurity and surveillance are worthwhile. Biosecurity is making a difference, and surveillance helps us to know what kind of impacts these pathogens are having. And and where those impacts are occurring. Alien plants that have a lot of native congeners, a lot of native species in the same genus, are going to be at the greatest risk of creating these pathogen spillover dynamics. So particularly where they invade our native ecosystems, this pathogen spillover is something we should be paying attention to. We also see that as networks change with the arrival of alien pathogens, these dynamics may become less stable and more prone to outbreaks over time. And with that, thank you very much.
Great, so we've actually done pretty well for time. We're keeping the time schedule, so it's now time for our afternoon tea break. I'd ask you to come back here promptly at 3:10 so we can keep to the timetable for the very last talk of this session. Thank you very much, and I'll see you shortly. All right, good afternoon. We're going to move towards the last lecture of the day. Obviously, the person who gets the last lecture of the day is really unfortunate in many ways, but we knew we'd keep you all here by saving the best till last. No pressure on you, Nick. That's, so it's a great pleasure to have Nick come and talk to us. Nick's the probably biosecurity everyman. I think in every single aspect of biosecurity in New Zealand, you can probably find Nick's involvement, whether it's myrtle rust, curly dieback, or the National Heritage Challenge, Bioprotection Core. Where there's biosecurity, you can find Nick. And it does so that he's in high regard and very well versed in all things biosecurity, and particularly in the Mataranga space. Now, Nick started his career as a plant pathologist in Manaki Whenua, and then moved to Auckland Council as a Chief Biosecurity Officer for 10 years. And he's currently with Plant and Food Research as well as Auckland University. So very few people in New Zealand probably have that breadth of expertise of CRI, university, and local government. So he'll probably bring some insights from that as well in his kōrero that he's going to be giving shortly. So Nick, without further ado, great to welcome you to the stage, and we look forward to hearing what you've got to tell us.
Well, kia ora tātou, save the best to last. Well, no, save it till most people are gone. No, but ngā mihi katoa, and I have swapped around a place or two. So I was going to, today I was just going to give some thoughts and insights at whatever the next slide came up, because our beloved Sandy has been after this talk for some time. And there isn't really a talk, because I'm going to pose some questions so I can go running up stage again. But hashtag Bioprotection 21. So kōrero, insights, reflections, progress, perspectives, but if you ever come to my lectures, it's more like a rant. And I was once told by a student, what you said had nothing to relate to your slides. So I've tried to have a few slides to go on with the kōrero. Now you look, don't worry, I haven't mislaid the slide. I looked at, well, what has the centre done? And we're talking about the future, but we also should look back to the past to think about how we go as Bioprotection Aotearoa and some of the amazing mahi and research that you've heard about today and where it's gone to and where it's led to. And I thought, well, what about Māori contributions to bioprotection and biosecurity? That's a good start. Travis, ngā mihi did in the opening, since I'm sort of doing a closing, I thought I'd look at where Te Ao Māori and what the Māori contributions to the centre have been. And this happened way before I was involved. And so that was our last talk, I think. So ngā mihi to my collaborators, conspirators, and other people. And acknowledging there's been a lot of people as part of anyone's journey, especially my own. So kia ora, Nick, Jamie, Mel, Amanda, of course, plus even Simon Lambert, who's not here. There's a lot of people that have contributed to our mahi, and here we all are. Plus the students. It's always about the students, and that's the pipeline, but the pipeline are actually real people, the tangata, and you've seen some of their research today, and they've just become brilliant researchers and are going to take Bioprotection Aotearoa forward in many other ways. And of course, ngā mihi to Matua and the Kahui Māori, an integral part of our journey as Māori researchers in the biosecurity, bioprotection world. So that was the aims, that was just a little bit of what that kōrero was about. And 2017, it's 2021, 4 years. And I would contend we're in a different place and space than ever before. And the journey of Aotearoa New Zealand, Te Tiriti, I used to go to conferences way back in places like Hamilton, and even the treaty wasn't known about. So it's the way the journeys that we have had together as a nation can be reflected in the science we do and the biosecurity system we work in. and protection of the taonga, Papatūānuku, Te Māori, it's very much integral to what we do. And we had some great kōrero this morning, and those ecosystems, the taonga, the whenua, the waiawa, what's at threat? So why do you do biosecurity? There's a whole lot of reasons, but it's these ecosystems that we are really trying to really look after in a way that we have to as guardians, kaitiaki, carers, protectors. And I think we're all on this journey together. We don't, we do it in agency, like 10 years in Auckland Council, Te Papa Atawai, MPI, the research that you all do brings together a thread that is all about where we go as Aotearoa New Zealand and beyond. So never lose sight in the biosecurity system of why you're doing it. And plant pathology is my journey through the biosecurity system, but we acknowledge that our taonga, our plants have been at threat for many, many different reasons for many years. And so I'm just going to splice through some of the random slides and sing out if you want to say anything or add anything to these wonderful, wonderful pests that we face in Aotearoa New Zealand. But the impacts that they have devastated and degraded and depleted and diminished our whakapapa, our heritage, and who we are as a nation, and how we, and especially as Māori, what these tipuna mean to us. So it's huge when you see your tipuna suffering like this. So it's not just the journey of studying a rust pathogen, it's about what it does to us as a people and to our taonga. And I mean, the Cook scurvy grass is a very famous taonga because of what it brought to, the first European that were encountering Māori. There's all sorts of issues and tissues about biosecurity from the start of this nation. And then journey through, remember Biosecurity New Zealand? Who remembers that? It did exist. I think it's coming back. So, we've worked within and with agency, and within agency, I want to acknowledge people working in agencies. There's passionate people throughout the government sector. You heard Mel talk about her new mahi in the Ministry for the Environment. There are real people working in agencies, and although it's easy to contend with working in agencies, and often seen as barriers or impediments, it's agencies like MPI, like Biosecurity New Zealand, that have brought New Zealand one of the best biosecurity systems in the world. And I remember delegations from Taiwan, Hawaii, all over the world coming to see and learn what Biosecurity New Zealand had put in place to protect our taonga. So I don't think there's enough compassion and, I guess, acknowledgement of people working in agencies for their mahi and their blood, sweat and tears. So kia ora to those people. And some of those are still in the labs in Tamaki. But you always have to challenge a system, and you have to challenge the science that underpins it. And so when we talk about biosecurity, risk, response, eradication, long-term management, you do have to think about what you're doing and what values and what, I guess, risks there are to our special ecosystems and our well-being. And I guess that's one of the, there was some kōrero yesterday about invasive insects. And I will also raise the flag for entomology. So I know there's a lot of entomologists in the room, and yeah, so we have to acknowledge it's a science system together, and this is poraporo. It's one of our taonga. It's often known as a weedy little thing at the edge of scrub, but to our people it's a blessing and in all its many forms. And so when the hadder beetle arrived, and ngā mihi to Margaret and Darren up in Tamaki Makaurau, who first raised, well, the hadder beetle does have risk to industry, does have risk to economic selenium, but it also has risk to taonga, and this is a tweet, hashtag, what's he called? Margaret, NZ Hymenoptera, in 2018, and there's the damage of the hadder beetle, which was on our taonga poraporo and hadn't been assessed across across the breadth of risk or biosecurity risk to taonga. And so this is where the Indigenous voice and Māori voice, Te Ao Māori, looking at taonga as having those special values as our tipuna and deserving thinking of in a biosecurity system has been a journey in itself, because we never used to, and in the system, we never used to acknowledge that. I mean, the system, we did, but the system didn't. So it's about system change. And I think the locals also like to munch poroporo, but I'd rather see our locals eat the poroporo rather than the hadda. So keeping things out like the hadda beetle is really important, but it's also what you do with it after it arrives. Now, here's a whittle, here's a challenge. We had a few questions in the morning about, and yesterday too. So, my amazing colleague, Albie Marsh, leant over on his phone and said, look, do you know this? And because virology rules the world, this virus has been detected in New Zealand, and being a pathogen of Solanum, well, again, that whole story of poroporo comes back. So if you work in biosecurity, you've got a job for life. So, and someone said yesterday, well, what do you do to get engagement, and what do you do to get some urgency into the system when there's, I guess, out of some of that questions, there needs to be hui, but there needs to be dui. And in the biosecurity system, there needs to be a rapid response when things like hadda or whatever arrive, or myrtle rust. So what do you do when you need to engage a whole range of kaitiaki and mana whenua, for example, and others who are working in their daily lives to look after poroporo, whether it's te papa atawai. Well, we had, how many years between hadda and PEP MV arriving? So we've often talked about what do you do, and MPI has often said that, what do you do in peacetime? So if you're in an eradication response, and everyone needs to know now, as the text went out to Albie, and that about this virus, but what has happened between hadda and PEP MV around poroporo and the risk and threat? So it's what you often do in what we call peacetime. And I know in biosecurity there often isn't, because if you talk to MPI, there's often 20 to 40 responses at any one time. But that's the sort of thinking and the questions that were posed yesterday about barriers or pace or timelines. And in the biosecurity space, it's immediate often. So that's where engaging along the way and forming relationships and partnerships and collaborations and building that sequentially and iterations through the system and through the motu, you have those relationships in place and embedded. And that's where the kōrero around te tiriti or the treaty and that partnership for a start is a start of how you do that. Because you know who to get on the phone and call, and you can work the kumara vine and the flax roots and the grass roots, and you can get to the people you know if you've built and established trusted relationships and partnerships. So that would be my answer to some of the kōrero yesterday, is how do you get that sense of urgency, or how do you, there's the paperwork, the bureaucracy, but timelines are important in biosecurity, and the timelines work really fast when you call the kumara vine, and next minute that's all in action. That's saving you a lot of time in the end. So that's my answer to some of that kōrero yesterday. If you have those relationships, you don't need to necessarily delay anything. Weeds. Weeds. And the reason I like to add in weeds, because my life was 10 years of weeds. But we had a little kōrero, and I've been really pleased the words social license and cultural license and social science have woven themselves through into this conference, and once upon a time you'd never heard such the words. In fact, it was like if you said there wasn't such a thing as social and cultural licence, let alone social scientists to study it. So we've moved in many ways in the system to see what the failings have been and why, and the answers have come up around why do people fear GMOs? Why do people fear biological control? Why do people fear RNAi? Why do people oppose it from the politicians through to the community and communities? Now that is because us as a system or a science has moved away from that connectivity, from having that open and frank and honest discussion, kanohe ke te kanohe, looking each other in the eye and talking about what we do. And I think that's a really important journey that, since we had the Royal Commission on Genetic Modification, what really has happened since then to really embed those philosophical stances through Aotearoa New Zealand. And it's been ad hoc, it's been disjointed, it's been here and there, it's raised in various rooms occasionally. I know I acknowledge the mahi of Genomics Aotearoa to put that out there, but really nothing since. So that would answer a question as to why there is no social licence, yet people moan there hasn't been. Well, there hasn't been that engagement, and there certainly hasn't, and I would contend, the research around those values that transdisciplinarity brings in, other knowledge systems, other beliefs, social science and the like, has not been embedded in right from the start from some of these new developments. But we're getting better at it. And that is, again, the dates matter. So the UN pesticide warning adds risks for New Zealand exports, glyphosate, GFR New Zealand, March 2015, and then we have the Japan market in our Manuka honey shipments, raising it, was it 6 years later? I would contend Aotearoa New Zealand has not had that conversation around the use of herbicides and glyphosate in the environment to the extent. So again, you talk about timelines, but we've had 6 years as a nation to really face up to this raru around glyphosate. So it's no use pitching that society doesn't understand the safe use of glyphosate and its need, and should we or shouldn't we, and should we use biocontrol instead of glyphosate, and are there mātauranga solutions in there that can also be thought about? Well, 6 years and it's just inflaming on. So I think that would be one of my answers to some of the kōrero again. So it's been, as a nation, we do have to face those issues, because otherwise it'll be another 6 years and glyphosate will be found somewhere else. So we come back to Te Tiriti and the use of herbicides, and I'm looking at the Tipuna Maunga Authority have made it very clear that chemical control on the maunga for weed control, or pest control, is not wanted. So what do we do as a nation to provide the tools that we're going to get to? The kōrero yesterday, 2025, pest-free, 2050, sorry. So again, it's having those conversations with people to find out what the aspirations are, what will work, what won't, and where is the rub, but where is also the common agreement. So there was some whittle there that I said I'd answer. So any reflections from that? I promised John I wouldn't berate you with a PowerPoint. And I've got this if you want to reflect on that. Just, okay. So these are some of the things that have been happening in the biosecurity space. I think license to operate is a really important thing, and also timelines are not only important, but social license isn't, yes, the community wants or not wants glyphosate now, and one of the case in points is biological control, which this centre has been a leader in the research and and developing them for implementation. But we heard from Dan Coop that connectivity between my own personal mahi, which was biocontrol of Tradescantia and Linley Hayes and Simon Fowler's team. Yes, there's knobbly, shiny and stripy, the Neolema beetles that have been released. But you heard Dan say this morning, well, where is it? The landowners with Tradescantia and the QE2 covenants don't have access to it. The regional councils and DOC funded that program at Manaki Whenua for those Brazilian beetles to be imported, yet still they are in the domain of a few labs here and there or someone's bedroom. So, so you've got to think about the research and its not only its where it gets to, but that implementation. And I think that was a really good point by Dan this morning to say we can do the best research in the world, but if it sits on a shelf in a paper, it's not really going to go anywhere in terms of creating some of that impact and reversing New Zealand's biological decline. And so a shout out to Marcus and Meikura, who are working in the centre at the moment to think about biocontrol for all that weedy problem in Auckland, Tamaki Makaurau, the weediest city on earth, and looking at does the cultural licence still exist, or did it ever exist, with the 22 mana whenua of Tamaki Makaurau for Auckland Council's biocontrol of weeds program. And it's a real essential piece of the puzzle, which timelines are dynamic and often change. You don't have social licence forever. Community values shift. So that whole raru around the GMOs in New Zealand really hasn't, there's been a little bit here and there, but it really hasn't been tested, I guess, and checked back in very well. So it's a bit ad hocery. And so doing the research that Marcus and Meikura are doing with mana whenua in Auckland, testing that even old tools in the toolbox like biocontrol, which has been, 40 years in New Zealand, 50 years in New Zealand for weed control, checking back in, because social and cultural licence isn't just something you get once. Okay, it's okay to do biocontrol forevermore. That's actually not how social licence works. So even understanding that is really important. And values and priorities can change in that time. And certainly for Māori, we have a whole lot of changes since the first biocontrol of weeds organism was brought into the country. We have iwi settlements for a start, so all sorts have happened. Don't worry, I'm not going to give you that. We all know about that, don't we? And I think, remember all those slides that never used to say human health was part of the biosecurity system? Wow, that's changed, hasn't it? One of the things I said in that talk in 2017 was about, at the time, the Asian towfly had arrived in Aotearoa in South Auckland, and of course Auckland was always in a sort of a semi-controlled area notice state with the Queensland fruit fly. But at the time, someone said, well, how would you engage the communities that are affected in the rohe or region where this Asian towfly had arrived? And these are the South Auckland mana whenua ropu, iwi hapu, that have interests in that very area. So nothing's happened since I put that slide up, by the way. So if something again happens in Manurewa of a biosecurity incursion, we're no better off than we were when I presented that in 2017, which is why I talk about the peacetime. Making those engagements and collaborations and partnerships with community is really, really important to keep on and keep doing, because I pointed that out in 2017, and I would contend that the same issue does exist if something else arrived in that community, yet we still don't have that connection in the biosecurity space with those communities and those really key people in a biosecurity hotspot. So Māori biosecurity was something that was the slide that was the slide from 2017. And where I say things have progressed, things are optimistic, things are amazing, is Te Tara Whakamātaki, the Māori Biosecurity Network, and acknowledging the people that have brought that together, Namahi Amanda, who actually wrote the first, was a VMKCF bid. So that was the first piece of funding towards it, and it's just bloomed and blossomed in a way that we could never have imagined. But it was a way that it was supposed to. The kaupapa was to get the word of biosecurity, the system, how it works, and who should be told about these issues like the PEP-MV and who you would connect to. And so we're having our trustee hui next month, but this is a huge initiative which has contributed to the biosecurity system. And so it's I think, a positive thing to think about when we look back. There are things that have changed and things that have changed for the better. And there's all sorts of, Tame has been doing some great interviews on the Kim Hull show and other things. You can hear about what he's bringing in terms of biosecurity and pest control. So that's just an example. Now, diversity in the system is another thing I wanted to talk about, just quickly. And that's something in the science system, in any system, what's the diversity? Well, you have these statistics that Tara and co have tabulated together that are pretty grim, even though we have a so-called vision mātauranga, which is really a brown box sticking in the research sector. But it's not all bad, because there have been better scales around what does VM and the treasure and the taonga that Charles Royal gifted Aotearoa New Zealand and MB. It's just not had any kaitiaki over or any care or treasure or manaaki in the 17, 18 years it's been in our science system. But things are changing. The MB with the Science Challenge and other areas, Te Tara Whakamātaki and other Māori Ropu, pushing VM to actually move with the times as well. So there's, the words kaupapa Māori research didn't exist. Well, they did exist, but not in the MB speak. So that is where things are progressing in a positive way. And that inclusion of knowledge holders across the motu, it doesn't necessarily reside in an institute. In fact, what we heard this morning from people like Dan Coop, knowledge and ideas come from the flax roots or the grassroots or the landowners or communities. It's really important to, if you want implementation, if you want connection, if you want to speed up timelines, to have those relationships of your communities of interest, and including always mana whenua. And we've seen some great initiatives coming out of those connections. Some more pictures. Back to weeds. Connections and biosecurity is not just about the motu, not just about Aotearoa New Zealand. You've always got to be, and MPO does this really well. It's one of the best agencies across the globe that thinks about what's happening elsewhere and what's on the horizon. But it means you also have to work with your nearest and dearest very closely, like this shows with the Phragmidium violaceum rust. So we already had these proof of concepts of these rusts coming across as biosecurity incursions. But by having those strong relationships or whakawhanangatanga with our nearest neighbours like Australia, Pacific, then you need to know what they're doing. So if they're, well, this was an illegal introduction, but that can impact on our biosecurity system. So having relationships that's not just within Aotearoa New Zealand, but it's also outward for these very reasons. And that, of course, includes our Pacific whananga, and acknowledging the hats off that the reason Bioprotection Aotearoa is happening from July 1 is the inclusion of Tangata Pacific. And that's a really significant, and with its own mana work and mahi and research that is going to be happening in the centre as well. So that was one of the directives from the Minister, that Tangata Pacific as part of Bioprotection Aotearoa. So that is part of the kaupapa that working with Māori and working with Pacific and beyond is also an important establishment as part of the centre as well. But we've always had those connections with our whanaunga, and hats off to people like Mel and Amanda and Albie and Nick Roskridge particularly, and all the mahi that he's been doing for decades in the Pacific with some amazing researchers. And you hopefully have met some of our Pacific champions. Don't worry, you will do. And so that's also an important part of working in a diverse space in the divided security and science research system. Communities, we heard a lot about that this morning. There are lots of invested communities across the motu that are important. They can add to your surveillance and monitoring program. And let's not forget we are a diverse community. There's all sorts of ethnicities and people that have interest in the biosecurity space. There you go. So, kia ora. It's just a few messages.
Yeah, no, you've done your exercise for the day, I think.
Questions? Oh, Rebecca.
Kia ora, I'm Rebecca McDougall from Scion. Jennifer, I really liked your talk, it was great. I was wondering if you can tell me, well, you said at the end of your talk that biosecurity and surveillance are really important, so that surveillance bit really caught me. Do you think we do enough surveillance across all of our primary sector?
Well, I think anytime you ask around biosecurity and you ask someone, do we do enough? The answer is always no. But of course, it's always a trade-off between doing surveillance and doing other things. But I do think we traditionally have put a lot of emphasis on what happens at the border, and that's important because if we stop something coming in, obviously that's the best outcome. But we don't actually know if we've succeeded unless we're doing surveillance within the country. And so I think what we saw in our data set was that surveillance has decreased quite substantially for plant pathogens, and that probably needs to come back up if we really want to be confident that we know what's going on. And you see this with things like the discovery of myrtle rust and other diseases that have come in recently. We're really reliant on people. One of the things that there's been a push for is to increase sort of citizen surveillance, and that's successful in some cases, but needs a lot of buy-in, and it takes actually a lot of expert time to filter through citizen surveillance results. So it's a complicated issue, but I think it's important and something we need to be thinking about more.
I think while we have citizen science through iNaturalist, the taxonomic limitations of some things mean that when you look at what's recorded on iNaturalist and you see what MPI have picked up, there's not a lot of correspondence. So the easy things to identify are fine. So we've heard a lot about citizen science, and that's a solution. But you really want a team of parataxonomists out there, people who've got, maybe universities should teach taxonomy a bit more, and that they have a basic training in that, and then they can actually be quite influential volunteers in a survey. Because I think currently, unless it's very easy to distinguish from a native species, it's missed by most citizen scientists, unless they're really good professional botanists or entomologists.
Yes, fighting over it. John Hampton, Bioprotection Research Centre. Jennifer, congratulations on a great talk. You made an association between the pasture and crop pathogens and New Zealand joining the OECD seed certification scheme. The OECD seed certification scheme has got nothing to do with pathology. It's only genetic purity for plant cultivars, plus some other things that individual countries add on. I'd suggest that perhaps one of those reasons was that in those days, and this is my first job as a new graduate from Lincoln was as a seed pathologist at the seed testing station in Palmerston North, where we were actually routinely testing imported seed lots for seed-borne pathogens. So that's one factor. The other, I think, is that about that time was the introduction of systemic fungicide seed treatments, which gave the ability to control pathogens that couldn't be controlled previously with the protectants that were then being used. So I think there's possibly some other explanations.
Cool, appreciate that. We had one of the things that we thought was important around that seed certification scheme was that it was just increasing the awareness of the importance of what was coming in the seeds and more attention being paid to what's coming in there. But yeah, I think you're right about the fungicide being a really important contributor as well. Yeah, thank you.
John, when Jennifer gives a talk again, are you expecting her to call that the Hampton effect then, when things start going down?
Yeah, I agree with Phil about the iNaturalist thing, that due to lack of the taxonomy details. The thing is, well, I started posting on iNaturalist from March 24th, since the lockdown started, yeah. I thought I had plenty of time, and then I posted about 2,000 observations. So whenever I can look at some differences, but if I post it and then name it, and then immediately answer comes that this is not in New Zealand. Nobody will think that, whether it is different or whether there are enough people to look at it, whether they are different or whether they are the same. I don't think we have that capability. So certainly we are lacking in that one.
That's one of the issues with iNaturalist is if something is not in New Zealand officially, but it's been found, there's a red light in MPI that flashes, and it's like everyone's got to go to the bunker immediately to figure out what they're going to do about it. So I suspect there's a lot of control on that, about things coming in that they haven't got clear evidence for. So that's possibly why you're getting that response.
Yeah, thanks. Here first, easier.
Kia ora, Vicky Ganley from Planet Food Research. So ngā mihi, Nick, for your talk, and it was really nice to see what's been happening over the year showcased, and also for you and Amanda and everybody else and the hard work that you've done to get that level of success over these years. It was really pleasing to see. However, if I compare that to what we see with women in science, we're decades on and we still struggle for equality and parity. And so just was wondering if you've got any comments, because if you're looking from an Indigenous perspective and you're looking at female in science to see how it's been tracking, it's probably not necessarily the best story to be looking at. So just wondering if you've got any comment.
Kia ora, ngā mihi. Becky, yes, and I think the statistics, I agree, it's even MB has put out a diversity in science paper, so that says something when they have wanted to lift diversity into the science system. And when you have Tara McAllister, her paper coming out, her papers coming out. So I do think there's a long way to go, and I think by having those, I guess, quantitative papers around women in science and diversities in science, it is something that we should be lifting. I don't know what the answer is. I think there's much a fragmentation of our system as well, and it's a really hard career because of the ad hoc funding, and so it's quite a fractured, fraught, competitive system to be involved with. So I'm not, but we do have to do this better, because diversity in everything is better. So.
Yeah, I think it's a big issue, but everyone's pointing out the problem, and no one's coming up with the ideal solution. It'll be interesting to see whether CRIs versus universities are better or worse. I mean, the environments there might be different. I think universities can be particularly toxic environments for both ethnic minorities and women. But I've never worked in a CRI, so I wouldn't know. But there may be a more collaborative environment there which brings teams together. and universities tend to be based on the individual and whoever, the squeaky wheel approach to getting support. So, yeah, it'd be interesting to see what kind of model of equity have we got good working models at all, and what that model should look like, I suppose. Yeah.
Hi, Jay, Plant Food Research. I had a kind of question for all of you. Everyone sort of mentioned myrtle rust in their talks. So how do we address a pathogen like that? So it's sort of coming in on, you know, quite naturally. It's not necessarily coming in on like a plane or on an import, unless I'm mistaken. So if it sort of comes in on the wind or comes in on the water and the rain, I mean, there's a certain amount of it coming in. What do we do? Like, climate change is obviously a factor. We're working on that. It comes into the country. We try and eliminate it. There's a sense of like desperation in my question, I know. Is there anything that we can do apart from engagement and trying to spread the news? But what activities do we do then?
Oh, kia ora. We're going to just keep this going because it's not just, you know, we have rapid ohia death in Hawaii and others. I think preparedness, but let's face it, we weren't prepared for the arrival of myrtle rust, even though we knew it was in Hawaii in 2005 and we knew it was in New South Wales in 2010. So although we acknowledged it and there was a little bit of mahi around the B3 program, that should have amped up given Eric McKenzie had published that 1 to 2 fungal rusts arrive across the Tasman since 1950. So we knew it was inevitable if that's how it got here. And it comes back to investment in preparedness, because as soon as it arrived, there was that mad scramble to seed bank when we suddenly didn't know what Syzygium myri did in terms of its reproductive fertility around its seed bank. We didn't know how to curate certain mutaceae. We hadn't prepared communities for such capabilities around seed banking. We hadn't prepared communities and mana whenua for which taonga in their rohe was potentially at risk from doing host range testing prior to it arriving. So yes, there is an inevitability, and that's where doing that horizon scanning and risk assessment is really important as a pre-border piece of mahi. And so if anything, that lesson is preparedness, so that rushing around the motu trying to do an urgent seed bank, which was critically under-informed with key pieces of information and key capabilities, we could have been responding a lot quicker in terms of when it did arrive. So that's one idea.
I think the challenge with something like myrtle rust is that a lot of our biosecurity is focused around keep it out or contain it and eradicate it. And that's great, and that's really important for a lot of species, and it's really basically impossible for a rust like myrtle rust. And I think because we've put so much effort into the border and eradication strategies, and because it kind of involves admitting that we can't eradicate, it's been harder maybe to do some of these other things that are around what do we do long term if we believe myrtle rust is now part of the New Zealand ecosystem. And I think it's a hard thing to say that that's where we're at, and that's probably part of why maybe we haven't done as much of that. But I think that's, yeah, as you highlighted, that's probably what's important at this point.
I suppose another thing is that when a pest comes into a country, people focus on the country's response and not the international consequences of it. So you wonder whether had Australia and New Zealand spent the resources they spent on their failed myrtle rust attempts, but actually gone and helped in Hawaii, would that have, who knows, would that have changed the outcome? But you might think that if we view our problems as an international problem, and this was clearly a pandemic species, could we have reacted in the same way as COVID, in that we say, well, this is a global problem, let's put resources together to deal with it at the source, rather than waiting for it to knock on our, to hit us one by one and use our limited resources that way. You do wonder whether a more global perspective of all these problems could target resources, particularly in developing countries, which are not that Hawaii is a developing country, but when the problems are arising in developing countries, they don't have the resources. But sooner or later, there's problems that are there are going to be knocking on our shore. And by the time they knock on our shore, they're going to be much more difficult to control. So that global perspective, I think that I try and promote in the One Biosecurity paper, would just change our perspectives a little bit. That might actually make things a bit better.
I'm going to add something to Becky's question because I was embarrassed I couldn't think of something positive to say. It is around the pipeline or the next generations of women and minority and others coming through that system and that support from a very, what we call tuakana taina, like looking after the cohorts coming through and ensuring that female and minorities and others are, cared, manaaki. The values of the new Bioprotection Aotearoa was around values and how we behave and initiatives like kindness and science. So if those initiatives are resourced and we have that whole manaaki over our rangatahi coming through and women, that's one way. I think it's a real success when you have a cohort that are looking after each other, that collegial support, and they become friends for life through and support each other through. And those mentoring are like mentoring. And New Zealand Bioprotection side at Ngā Mihi area, we've thought about that, haven't we? And having mentors through the system and resourcing the time to have mentors in the system. So I wanted to say something about that.
If I can add to that as well, Nick, it's Rebecca here again. I went to a women's leadership conference once, and it was more than just about women's leadership, it was about diversity in general. And one of the things that they said in that meeting was that if minorities are not intentionally included, they'll be unintentionally excluded. And so while some people don't agree that, on a particular committee you should have a certain number of women or a certain number of any minority, because quotas are not based on merit, if everything's always based on merit, the people who have the privilege are always the ones that will be at the table. So that was one thing. And then the other part of that is that we have to acknowledge that women are in more cases than not, the primary caregiver of our offspring. So that makes it really challenging when you have to go to a conference, when you have to write a grant, all of those things. So support for women and other minorities to be able to leave their homes to do these things or spend extra time to write those grants is where it's needed.
I might just add one other thing briefly onto that, which is that I think initially a lot of the focus was around getting more women and minorities into the pipeline. Let's get more postgraduate students in. And I think what we're finding is that that's not enough, that we sort of assumed if you get them into the pipeline, then you'll automatically get higher representation at other stages. And I think part of it kind of comes to discussion that we've been having over the course of this conference around values. And we find that people coming from other cultures and women often have a different set of values or priorities, which means that the way they approach the work is going to be slightly different and what they value in their work is going to be slightly different. And I think, at least I'm seeing more flexibility in academia and other institutions around recognizing those differences and trying to embrace them rather than ignoring them. But that is probably going to be important as well in bringing in people.
Daryl here in Scion. Just getting to changing the topic a little bit and wanted to speak a little bit about like lists that we have for pests and pathogens coming into countries, and also the issue around taxonomy of some of these things as well. and understanding the biology of the organism. So we have names on papers, and to some people, some organizations, those names mean different things. Some people, some areas, or some countries know more about those. Some CRIs know more about those pathogens. And yeah, I don't think in a lot of the cases we understand, or at least the people making the decisions don't always understand the detail below the name of that species and below the species level. So also looking at, I'm going to use Fusarium cicinatus, a pine pitch canker, a massive problem for radiata pine in the world, only recently being found associated with grasses. You know, grasses being moved around the world, potential pathway, but it's not, information's not being, you know, shared about that. And then the issue of species complexes as well. So things like Fusarium oxysporum, in a lot of places, people consider that one thing, but it's possibly hundreds of different species. And some of these things are pathogens or not, and then they all kind of fit under the same banner, which can be a problem as well. Solani, another one. Incarnata microceti Fusarium is just a mess. But people don't understand that, so that has big implications for biosecurity and taxonomy. I think wasn't really addressed too much in this meeting, but I think it's something that we need to think about for securing and understanding what those names actually mean.
If you take the human health, which they also have pathogens that sometimes appear and they don't know what they are. But what they do have a wider community of interconnected individuals who send news feeds through a system where they say, hang on, something strange happening here. People are coming, being reported having a fever in Mumbai, etc. And so that goes up, and people, oh, that's interesting. We heard that in Korea 2 weeks ago. You wonder whether something that's much more connected for biosecurity would be a thing. At the moment, I think New Zealand had an early warning, MPI established a kind of an early warning horizon scanning thing where individuals could say, oh, I went to a conference and I heard somebody doing about this, and sending it to MPI and assuming that it was acted upon. But this kind of network of expertise across the science spectrum might be a way of doing that. So, you know, you can imagine in Scion, you'd be looking for news feeds that would be relevant to forestry species. And so then, you know, you'd get these messages coming up saying, oh, by the way, we're dealing with this pest, we've not seen it before. Whether that's a solution or not, I'm not sure, but it seemed, certainly with the COVID outbreak, there was early tremors, there was early signals of that before the official announcement from China. And so I think that if we can have that trusted network, we might get away with at least early identification of potential risks that we should be looking out for.
I'll just second that taxonomy is really important, and that's always going to be a limitation of the analyses that we do and the border lists that we have. We have to have a name on paper, but you're right. And even where species identification is difficult, or different races within a pathogen have different impacts, I think it's a warning. I think it's an emphasis on the importance of that one biosecurity, that we need to be keeping as much stuff out across the board as possible, and not just assuming that because name on paper is already present in New Zealand, it's safe to let it through the border again.
I don't know whether, Phil, you heard about the mucormycosis in India. People who have recovered from COVID, because of excess use of steroids, they became susceptible to infection by mucor. And several people who survived COVID died because of mucor infection. They lost eyes, they lost limbs, and so many facial parts, you know, they had to remove nose for some people. Yeah. So that, yeah, a commonly occurring fungus, just taking advantage of, you know, the misuse of steroids. So I think one big biosecurity system is really good to look at.
Well, on that cheery note, I might call this session to a close. Thank you, Wadia. And can we thank our three speakers, please? To do a proper summing up, but I will say it's been a wonderful couple of days, you know, really thought-provoking talks. We've had some reflections on what's been done in the last 5 years. We've heard from some of our alumni who are going on to bigger and better things. We've had some perspectives of what the future is going to look like for Bioprotection Aotearoa, and a bit of a hint for you of what it's going to look like, which is really a huge movement from where we've been for the last 5 years. And I think Nick has summed it up a little in that we went from an area where it was a Maori program attached to another science program to a program that is going to be integrated and really try to push the boundaries of both the science and the interactions. And as I think Becky was mentioning, there's some efforts around the equality across the board. How do we do that as an organisation and keeping that at front of mind? So, very bold program, and going forward, it has been a really wonderful program for the last 5 years and what we've managed to achieve, and it's evolving quite nicely. I do thank you all for your participation and so many of you staying to the last, which is great to see. And I will wish you well on your travels, and I will invite Matua Hanare to close, please. Oh, sorry, my apologies. Biggest thing. Thank yous. The program was designed by Amanda. She decided on the speakers, and I think that was, you can all agree, that was a really good mix. Not quite the conference we've done before, and so much more enjoyable. Behind the scenes, Sandy, I think most of you have had interactions with Sandy, who's been trying to herd the cats and get everyone here and then get them home again. And so thank you to Sandy and to Michelle and the office staff. Oh, there she is up there. I thought she'd be out doing something, but my apologies.
Kia ora koutou katoa, and Sandy, of course. Tēnā koe, Sandy. Look, it has been a wonderful couple of days, though at times tinged with a bit of anxiety with those of us from Wellington who had to depart early. Our thoughts obviously are with them, and with each and every one of you. Within this closing prayer, whether you come from near or far, we will be asking that you you make safe journey home to wherever you may come from. And also included in this, we will bless all who have attended here today, and of course, your families. Quite a diverse discussion has taken place. It's been really great. And I guess to some extent at times it has tested what is biosecurity. And to you, my dear, you added in there a very important component about our mothers, mums and dads. For without them, you and I wouldn't be sitting here today. Nā reira kia tātou katoa kia ino I tātou. Ei hoa ngā mano tēnei rā mātou āwponanga. Āwponanga iti e inake nei mātou kia koe I tēnei wā. Kia tata mai rā koe kia mātou I roto tēnei te whakakapinga o tēnei tā mātou hui. Nō reira rā ei hoa tēnei ka inua atu nei mātou kia koe. Ke manakitia hoki a mātou katoa e noho tahi mai nei I raro te tūnui o tēnei tā mātou whare. Rātou kua wehe atu, kua hoki ai rātou, kia tautonunga manaakitanga kei rungi a rātou. E neo mātou whānau katoa, o mahi rātou, kua hoki ai, kia tai rātou ki o rātou whānau. Me mātou hoki e noho mai nei. Nō reira ka ino tonu mai nei, mātou kia koe I huanga mano. Tēnei rā mātou whakapono nei mātou te tangata katai ai mātou etahi mea. Whakapono nui ai mātou e I hoa katai ai koe I ngā mea katoa. Tu auriuri whai o tēnei ka whakahoki atu rā kia koe. te honore, te kloria i tēnei wā. Nā reira ka inai ai mātou i runga tonu to ingoa tapu to ingoa kaha. Whakaungia mai mātou roto tō koutou aroha mutunga kore. Pai here kia ki te rangi mārie i ngā wakatoa. Kei roto tonu ko koe te māngai te kai ārahi kai tautoko mai, ai nei, mō aka nei, āmeni. Tēnā tātou. Go well.